I normally don't use the screen sharing setup mechanism, so I presume this is okay for everyone because.
Yep.
Great. I've got a party going on across the street, but I'm also using the RTX voice setup that I think actually works really well to remove stuff. But also I should verify, does my audio sound okay? Sometimes the audio processing stuff messes with my audio, but I think that the RTX one was always pretty good.
You sound great. We're good.
Sounds good to me.
Great. You know, and are you hearing the party out of curiosity?
No.
All right. I live in Fratland. I'm on El Greco, Freak Road. So I'm surrounded by like 3 frats. So, okay. And I've got, is this still set up to work? Yes, it is. I've got the presenter, you know, I'm sitting here, and I've actually got multiple people set up to do all this. So I'm using the actual little slide presenter thing, which is probably going to cause some horrible problem later on in this. But often when I give talks like this one, I'm using a eclectic slide deck, just a massive set of randomish slides that we're going to go have some fun with. But this one actually, as you'll note, says that I gave the talk at PAC Illinois 2020, not that long ago. I actually went through and I carefully organized out a single thought process, which may not actually be the most fun thing here, but at the end of this, we could even pull up another random slide. But this is at least coherent. And I can probably just use a slide presenter in order to go through slide by slide. One other caveat, however, is I did not, although honestly, even though I always say that I should, I never do for this talk, and I've been doing it for years. So I think it's actually fine, and it's almost even better because my knowledge of the talk comes from doing it like this. I did not look at the slides ahead of time, so I do not remember. There's going to be some code on the slides, and there's going to be at least one of them where I'm just going to be staring at it going, what's this do again? But it'll be fine. Okay. Yeah, originally, I should also do that. This thought process that, again, I kind of cut out into a talk for Hack Illinois was part of what was originally a very small portion of a arguably much longer talk. I mean, I've got a version of this that's like hundreds of slides that focuses more on the Digital and Copyright Act and all the work that I do and the premise of what bugs are. And I think this is just going to have one little section touching on the premise of bugs, but otherwise it's largely about the code itself. And if it doesn't, for you, I will, if it doesn't have at least a little bit of it, I'm definitely going to pull up a bit in front of their slide deck. But I copied a bunch of them, more of them over. Oh, and the only thing I should verify is get that and get that. Do you want people to join live? Okay, great. Okay, perfect. Yeah. So hello. This is, I guess I will now repreference quickly because I'm the title slide here. Secure coding practices. And when I gave this talk at Hack Illinois, I don't remember who set the title, but I found the premise of, they called it practices. I honestly that wasn't really exactly what I pitched, but they didn't really care what I gave a talk. It's not like we pitched them a talk and they let me give a talk. So they wanted me to give a talk. And so I don't remember exactly what happened with this title, but that's what's going on there. All right. As you, in the, this audience certainly all know, my name is Jay Freeman. Everyone online knows. Everyone online knows me as Sork mostly. My work on jailbreaking. I tend to also have then in all these talks a slide presenting who I am, and it's always though slanted towards whatever the content of the talk is. And there actually is a couple details on here. One of which is I grew up near Chicago, which was where Hack Illinois was. That's why. That's I just pulled up the Hack Illinois slides. I teach at UCSB CCS, so you all know that. But what you might not know is that I'm the developer of Anacrino. So I mean, you probably don't even know what Anacrino is, but I'm the developer of Anacrino. So Anacrino was the first decompiler for .NET. I I mentioned this when we were going over C++ at the end, that I was heavily involved in .NET beta and all, and managed C++. But part of the reason, part of what ended up happening with all that, like part of the reason why I was so deep into all of it, is that I was on the .NET mailing list, and people kept talking about how one day somebody's going to build some kind of decompiler, and because we've got all of this high-level bytecode that everyone is working with, somebody's going to be able to reverse engineer it and understand all of our code. And these are a lot of enterprisey, businessy people who were actually, there was an issue, they were concerned about it. Microsoft added a flag on their disassembler that would refuse to disassemble in protected binary, which I thought was kind of stupid, because it's not like, it's like, what is it really going to do? It's not, it can't be encrypted in some way. There's no protection mechanism that would make any sense here. But people just kind of wanted to just brush off the thought process, because it's going to take forever to somebody to build a decompiler. So I ended up writing a decompiler. It was called Exemplar, the first version. There's a command line tool, and that reversed out a lot of the semantics of the C# programs. And I implemented that little protection flag, and I couldn't figure out where Microsoft was storing it. But I think I figured out a year later, but like I could figure out Microsoft was actually storing the information about that this binary should not be disassembled. So I just didn't implement that. And so there's this program there that could even decompile things that no one could run through the disassembler. And everyone was like, oh, that's interesting. So I ended up then building a graphical tool that allows you to really explore down deep into programs, and would like rebuild out IDE like object models for the whole thing. And it was called Anacrino. And there's another program which you might have heard of if you're in the space, that's called Reflectors, made by Lutz Roeder. And he was almost even like weirdly competing with Anacrino and things, and trying to like add more decompiler features. But my focus is really on the decompiler, and it's quite powerful. But this is like, for a long time, I've had a background in static analysis and kind of tearing apart parts of programs. And I ended up then getting involved in the iOS jailbreaking scene, where I was providing a tool chain and then a lot of the low-level code injection support and stuff like that. That led to, I'm assuming this is, yeah. I forgot that I got this. It's a cool transition slide. With all the jailbreaking work, we end up going to DEF CON every year. Although actually I ended up cheating on that, but that's a whole different story. I didn't stop going before the pandemic. I stopped going to the event before the pandemic, but I still was going to the area because there were people that I was working with who would be around there. This is actually from, I think it was when GeoHot won the Pony Award for starts with, no, it doesn't start with, it was at oh wait, the lock. Futex, it was the Futex Requeue bug. And for some reason I'm still, we have the name in the slide later. But he managed to win a Pony Award for one of his exploits. And we ended up going around all these after parties and everything. And I don't really party. I just sit around and work on my laptop. And that's what somebody ended up taking a photo of here. What was going on behind me was this. The reason why I think I left a couple slides in here was because as the group of people who were working on all this hacking and everything, we spend a lot of time in Vegas, and actually we particularly spent a lot of time at the Rio, which is Penn and Teller's home venue. So Penn and Teller are rather famous magicians. I almost said musicians, are famous magicians. And really their whole shtick is that they do a magic act where they do a trick, and then they show you how the trick worked. Something absolutely trivial, which it kind of goes very anathema to how magic normally works, which the whole point of magic is that you do a trick and you never show anybody how it works. And then the whole point of the exercise would unravel if you just started showing people, what you were doing. Penn and Teller, their whole thing is that it's actually fun to learn how all of these tricks end up working. And they do tend to then have another overarching trick that kind of is going through their performance, and that they kind of might leave that as a mystery. But they've actually got a lot of like backlash from magicians at times over, you know, you're giving away our field, but other magicians have been like, no, you know, they're giving away the boring stuff. You know, it makes people find all the more mystified when we actually trick them. They then actually have a television series, which is like magicians come and then they do their trick, and Penn and Teller quickly talk amongst themselves and then try to figure out how the trick worked, and then it's called Fool Me, and then they have the magician come down, actually, because they don't tell the audience what happened. They have the magician come down, and then they're like, was it this? Like they whisper, and the magician's like, yeah, you got me. Or Penn and Teller don't, and they got fooled. Interestingly enough, this whole show is about trying to figure out what happened, and then they never tell the audience what happened. It was just about whether or not Penn and Teller got fooled. But that's their shtick. And I started seeing a lot of, I would say, parallels between the world of magic and the world of hacking, where there are people, and people like GeoHot, for example, who find these exploits and then they kind of sit on them. A lot of times, people actually they'll hoard exploits, and they will use them in order to be able to do feats of debugging magic. There will be some piece of software that everyone wants to analyze, and no one has a copy of it, and then somebody will be like, well, I somehow managed to extract a copy of it, and here's how this part of the protocol works. And it's because they've been sitting on a 0 day for the backup or store mechanism that allows them to pull something out. GeoHot does tend to sit on a lot of bugs, and so if you're like working with him or talking to him about something, sometimes he will just like pull off some random trick, and you're like, "How did you do that?" And he's like, "I know some stuff." The talks then that you get, they're unlike in World of Magic. There are like very organized talks. You go to like a 2-hour-long presentation about how some specific bug works. I don't really find them to be very implicit. They don't manage to entertain. Let's put it that way. I was once. I mean, I was kind of riveted. Went to like it wasn't Ponty G. It was. I think it was Nikias, gave a 3-hour-long talk that we'd actually only scheduled him for like an hour. He gave like a 3-hour-long talk on one of his exploits, and it was very dry, just to be honest, and it lost the entire audience that was there, and all the people were trying to watch it later. But the material was all very solid. So the question for me always was: is that can we distill down? Can we take some of like actual, not just like toy examples, but can we try to distill down the core bug out of a lot of real world examples, and then try to describe those in a way that could be entertaining? And that's where this talk tries to go. Extra slide is the mystery when you don't look at slide decks ahead of time. So I guess I just went through it. Here are some of the kind of crazy hacker types that we end up relying on to do all these sorts of work. And so I've been talking about GeoHot. He's the guy in the white shirt. And then POSIX Ninja is the guy. I'm just trying. My brain is not very good at nouns, and then it's not a good day for nouns, even extra for me. Is the guy in the green shirt, and then he did various chronic dev tooling, but there was one in particular that Green Poison, hence the green shirt with the skull on it. And then to his right is Nito TV, between POSIX Ninja and myself, who did all the exploits for Apple TV, including before Apple TV was based on iOS. And there's me. And then to my right is Kroo, Kroo, who was involved in some of the very early, like the pre-Cydia jailbreaks and the installer community. To GeoHot's left is Jaywalker, who was also heavily involved throughout the time, and then continued to be involved later with Nito TV on Apple TV stuff. And part of the reason I go through all of these people here, actually also in the mirror is Britta. You can just barely see her, who was working with me on, and was a CCS lit student. But Britta and I were kind of like the core of the Cydia community always. And then to Jay Walker's left is Cody Walker, who CCS CS student who happened to be with Britta and I, and got in every single one of these photos, and it became like a running gag. Actually, we purposefully was injecting into all these photos, but that's Cody. We oftentimes end up exploiting phones. That's apparently what this must be about. On the bottom right is Planet Being, GeoHot in the upper right, and then on the left is Charlie Miller. He did, I think, actually even more notable than any of his phone stuff. He did a big hack on the Jeep Cherokee, but the bug that he found allowed him to remotely. I think actually it sounds ridiculous every time but I think actually every time I check, it's like he found remotely disable the brakes on any whatever I think it was the Jeep Cherokee, and actually got a reporter to like be in the car and drive on a highway while he remotely disabled parts of the car. And there was a big issue about hacker ethics on this. It's like, was that a reasonable thing to do? It's like, even if the person who was in the car gave consent, should he be giving such weirdly deadly consent? Was it safe for other people on the road to be doing this? I think there just weren't really anyone else much on the road at the time when they were doing this on purpose. But that was one of the big ethical questions that came up. GeoHot has later gone on to work on like self-driving car technology. And Charlie, I think after that exploit, worked on trying to. He really wanted to remotely cause a MacBook battery to explode. He got really close, but it did not get that far, sadly. But he did. Apparently there's an administrator password on the battery for doing various firmware updates and things on it, and it was like a set of numbers, like a pin code, and it was all zeros. So that was what he managed to get as far as being able to like change a lot of behaviors on the battery that were doing battery management. But I actually didn't remember that I had this many people. But so Dan Rosenberg does Android hacking, and he specifically works on Linux kernel information leaks. So there's an issue where when you want to exploit the behavior of some program, and you've managed to alter its functionality, but you need to be able to get access to parts of its data, or you've been able to like modify its you've been able to like modify parts of its memory, but you don't know where anything is. And so it's really convenient if you have some kind of bug that it doesn't let you change the behavior or write anything, but allows you to maybe read a little bit of random memory. Because if you can read a little bit of random memory, you might be able to figure out where a pointer is located, and really figure out that something is a pointer, and then figure out where in memory something is, and then use those as landmarks. The Linux kernel team did not treat information disclosure bugs as security issues, but every attack on the Linux kernel relied on an information disclosure. And so Dan made it his like mission to just try to really force the issue on Linux kernel developers, poking at here's information disclosure, and here's the jailbreak I pulled off because of it. Here's information disclosure, and here's the jailbreak J-Case pulled off. I mean, he's probably the next slide. J-Case, who did his whole thing, which he will be referenced in a couple minutes. His whole thing was about finding low-hanging fruit and then plucking it everywhere. And I find actually some of J-Case's bugs, they're like the most ridiculous things that like how could somebody have made this kind of mistake repeatedly? And so actually I'm gonna leave that with the actual, because I'm certain I have a slide. Next slide, but probably not on that. What was I doing in Hackulate? So I do a lot of work on runtime code modification, and so that's what Cydia Substrate does. It's kind of like the slide in the. One second. I'm just going to Okay, I apparently just explained this. So let's do this. Okay, so I do a lot of work on runtime code modification, and I really was trying to construct some kind of environment that allowed you to run a normal program, and then while that normal program was running, change its behavior. And there's like a whole there's like a whole class we oftentimes do, Murad and I, on I'll talk about aspect-oriented programming, and Murad talks about contracts and everything. But because I've got photos of this here, and I probably won't have easy to pull up photos at the time, or it'd be really annoying to set up a projector for like one thing. I had spent a lot of time when I was a kid playing with the Game Genie. I really enjoyed working with the Game Genie, and the Game Genie is something that I think made a lot of people get to experience something about the fun of hacking. So when you're kind of hacking software, when you're like hacking on software, you're like hacking into software and everything. There's like, what are you doing? And like, one thing you could do is you could go in, you could like steal a bunch of information you're not supposed to have, or you could destroy a bunch of information that other people want to have secure, or you could corrupt information so that people don't know what's true or what isn't. The Game Genie feels, particularly in a world, I mean, you don't really have networks. So the Game Genie was a tool that would for like the original Nintendo, the one on the left, the Nintendo Entertainment System, that would plug between the cartridge and the Nintendo. And so you plug the cartridge into the Game Genie, then you plug the Game Genie into the Nintendo as if it were a cartridge. And what the Game Genie would do is it would modify bytes of the program code as they got read from the cartridge to the Nintendo. And when you like booted it up, what it gave you was an interface that allowed you to program it and type in Game Genie codes. And these Game Genie codes were so kind of weirdly mystical, and so it kind of ties into this whole theme here of they were like 6-digit numbers or something, like 6-digit text numbers or something like that, but they didn't really map directly. You try to think of like, well, what actually I want? I might want like a 2 or 3 byte address, and I want like some kind of value I'm overriding. You didn't really map directly to that. Like it was this code that was generated with a slight reorganization of bits on an address and a value. And then they would give you this code book that came with the Game Genie, and you could also get like extended codes later. I think they had some kind of deal with Nintendo Power in order to distribute stuff. And that kind of was weird. It must come after. If they did that, it must have been after the lawsuit. But it made it so that the codes were just barely like editable enough that if you just kind of change the code you already had, it might do something interesting. But also were opaque enough that even somebody who had some knowledge of what they were doing couldn't really directly see how the Game Genie worked. Like you kind of knew how the Game Genie must operate, but the codes were just magic that somebody would come with an incantation and be able to make a change to the software. And I am going to skip this explanation because we will do this in a different. All right. I started kind of describing this as similar. Actually, there was a DMCA triennial rulemaking hearing that I was involved in once, where the argument was about whether or not jailbreaking particular set of devices should be allowed. It should be explicitly exempt. Whether it was already exempt or not is an interesting question, but whether it should be explicitly exempt. And that's right. Even actually, this is even better CCS connection. I remember the exact moment that this came up. There was a panel for jailbreaking video game consoles that the Electronic Frontier Foundation no longer bothered to file for. They no longer bothered to actually put in you should, like, we want to be, the petition is the term for it. And so they also didn't send any lawyers to the panel. The person who petitioned for it was just some like random person who is just interested in it, and he filed like a 3-sentence long petition. It's like they actually care at the top of your office. So they've got a multi-stage public comment experience, and you can just go in and provide a 3-sentence explanation of what you want to have happen, and then all the lawyers start working on it later. So somebody from like the Free Software Conservancy or something provided some argument about the video game stuff, but the Electronic Frontier Foundation didn't want to do it. No one was at the panel. So Kyle Wines and Kyle is in charge of iFixit. just asked if we were already there. They already had name placards for us. We were already kind of in the system. Can we be on this panel? And Kyle, was the person who kind of pitching me on, we should try the Hail Mary pass. If none of the lawyers are going to do it, let's do it. The shtick we put some little planning into it, and the shtick we came up with was that it was almost like a good cop, bad cop sort of thing. So it's like I was going to be making this extremely radical argument that code modification should be allowed, and then we should be able to support full jailbreaking like we do on iOS. We should have weekend managers and all sorts of, and then substrate-like technology that allows you to change the behavior of all the running programs, things like that. And Kyle was going to be the compromise position on, look, I'm just trying to repair the optical sensor in the DVD drive on this Xbox. And they think about the amount of waste that is being put into landfills. Think about all of the amount of rare earth metals that are being mined out of China that are leading to all sorts of intergovernmental politics issues that we keep talking about, that we really we're just wasting it. And he actually made a lot of progress to the point where the people who were there for Microsoft were actually looking notably concerned that the panel was really reasonable. But I was kind of making this I was sitting there having to defend what I do, and I ended up bringing up an example. I actually don't do quick games, but Sasha. Is it Sasha Cohen? That can't be right, because there's Sasha Baron Cohen, who's the famous actor. Sasha, who's a CCS CS student, he had been doing a lot of work with a game called Spelunky, where he would do runtime code injection. He actually had built an online multiplayer version of what was this offline procedurally generated video game. And editors and all sorts of stuff for it, and he only had the binaries for it, and he was making all these modifications to it, and I was explaining all the stuff, and I was being grilled by the copyright office. Did Sasha have permission to do these things? And might not, that he was distributing modified versions, all sorts of stuff. And Sasha was using the kinds of techniques that we're doing for runtime code modification, where the program runs, and then once the program's running, you would kind of redirect one function to another function, or you would edit and patch it in memory. Sasha wasn't redistributing the original. Sasha wasn't essentially violating the copyright a lot of these things. He was providing, and I ended up giving this description. There's this, which you may or may not, it's sufficiently famous that it's people have been talking about it. I know somewhat recently, even though it was a 2005 skit, but and it's not I actually never even really liked Saturday Night Live. So this skit only really came to my attention in recent years. But recent years for me are still maybe 7 years ago. And I don't know if any of you even recognize this, but there is a skit from Saturday Night Live that was weirdly famous, where his name is Will something. This was SNL. Will Ferrell is the cowbell. He's playing the cowbell. There's a song called "Don't Fear the Reaper," and there's a cowbell part. And Christopher Walken is the producer, and all of the band is really annoyed that there's this cowbell in there, and the producer, is just really loving the cowbell, and it's constantly I want to hear more cowbell, more cowbell. And that's the typical Saturday Night Live skit, that was just one kind of cool little premise and kind of blows up. But my argument was, what if you were to just have Don't Fear the Reaper was being sold, and then somebody else were to, on the side, and even sell a record that had nothing on it but cowbell, and you were told to get two record players, put them next to each other, play them at the same time, start them, and then you would get the cowbell track that would add more cowbell to Don't Fear the Reaper. And going down this argument path, that I was hearing that all the lawyers who were there for the entire thing are maybe not on this particular panel, where this one really didn't have any lawyers on our side. Kind of right behind me, very close to me, actually, an audience panel. I kind of finding this whole process, I could just kind of hear almost giggles. I'm going down this convoluted path to try to explain why what I was doing was allowed. And I provided the Game Genie analogy. I was now providing these cowbell analogies. And a judge is not getting it. I hear the electronic frontiers for not judge, the representatives from the copyright office are not getting. I end up hearing this like from behind me from the Electronic Frontier Foundation lawyer, of course, didn't even want me to do this in the first place. And I'm just like, is he just thinking that I've lost us the whole thing? Like, later on, our jailbreaking panel, we're gonna end up running into problems because I've made this ridiculous analogy without having any lawyers in the panel. And I talked to him afterwards, and it turns out the reason why he was sighing was not because my analogy made no sense or that I had lost us the case. It was because he was so upset that the panel didn't know the case law and that my explanation fed into, because I apparently cited the perfect thing by citing Game Genie. Nintendo sued Galoob over Game Genie and lost because it was ruled that there is no copyright infringement if you do this more cowbell-like thing. And that I had provided this glorious end-user-oriented analogy to explain this legal issue that ended up happening, and that somehow the panel did not know that it was all correct. And so we ended up with that legal reference, when we started the jailbreaking panel, because it was also my same software that was kind of going to be relevant, I was able to kind of bridge that back and re-explain, by the way, this earlier, and I've read the actual paragraph from the judge in the Nintendo v. Galoob case about that. But finally, we now kind of bridge into these issues. So I do all this work, and I was doing all this work for some of the early iPhones, and Android is coming out. And a lot of people to this day, very frustrating to me, will talk about Android as like the open alternative to the iPhone. And it's really not the case. Most Android devices are locked down. Most of them, if you look at the amount of money that people actually are spending on Android devices, most of it's going to Samsung, and a lot of the Samsungs are locked down. There are Android devices that are more open, that do allow you to do bootloader unlocks and things like that. But it certainly wasn't like the premise of them. And in fact, here is the T-Mobile G1, which is the first consumer-oriented Android device that came out. Actually, it might have just been the first. There wasn't anything with it. There was all of emulators and things. Google bought Android, and their Android at the time was kind of targeting BlackBerries, and all the emulators were kind of BlackBerry targeted. And I don't think they actually ever built one. So this was the Android device, and this was locked down, fully locked down. The question was, will there be a jailbreak for it? And I told a lot of people, if you have a jailbreak for it, I will support your platform and do some work on it. And the first bug that we found was ridiculous. And so this is actually a bug report from not about the jailbreak. This was a bug report to ConnectBot, which is still a very popular SSH client for Android, which came out very soon after the device came out. And the issue was, somebody goes in the file, it's typical bug report template. What steps will reproduce the problem? So you connect to a remote, here's the remote Unix machine. You type reboot, and you expect the remote computer to reboot, but the remote machine rebooted, but as well as the phone. What is the expected output? What do you see instead? The expected output is to reboot the remote computer. Instead, the remote computer rebooted as well as the phone. So somebody starts digging into this, and they managed to figure out that there is a console attached to the keyboard. So the keyboard on the Android device was set up just like a Linux keyboard device. And there were systems that were reading from that keyboard in order to inject into the userland UI interface. But Linux also is set up to have these base consoles, TTYs, that are attached to input devices. And the Android initialization system had support for that with these consoles. And they had a console set up that was just a shell. And if you by default just put this into your config file, it runs as root. And it turned out that anything you would type in, you'd be texting somebody, and everything you were typing was being typed into a shell, and you were hitting enter on it, and it was running in the shell. Thankfully, most things weren't valid Unix commands. And they didn't have that comprehensive Unix tool suite on there, but they did have reboot. So you type, if the previous thing you had typed was something that ended like, if you typed an enter, you have to hit like a new line also. If you just like say like hello reboot to somebody, that would be the command hello reboot. So you had to like enter reboot, followed by what it, that rest of that will end up getting orders arguments. Enter, reboot the phone. Because the thing that really sucks about doing these, and also the thing that I'm not very good at, which I think is actually just forcing me to do practice on, is just talking to a wall. Because some of these moments are ones where I'm just like, you're used to doing things in front of a live studio audience, and you like get to a point and you're kind of like looking around, you're kind of expecting there to be like smiles and like, they pause for laughter and reaction and some of these, like the ridiculousness of some of these bugs. But Google happened to provide very conveniently for us a telnet daemon. So if you just went into any, just something that would ignore keystrokes, and you type enter, telnet, de-enter, it would run a telnet daemon. To be clear, it didn't have to ignore the keystrokes. It was just probably didn't want to like actually text that to something. And then you get a telnet daemon running as what? And so then you'd be able to SSH and telnet into it and then start working with the system. And it actually still wasn't really a very complete jailbreak because we were running into issues with you couldn't really modify the kernel behaviors. You just had root access, which at least was better than now. And now they can see Linux and all sorts of things. But we ended up, it took us a while longer in order to get to a point where we could actually dump the firmware, the flash memory blobs. And I actually ended up creating a mailing list, and we had like people from it was kind of cool because the people in the Android software team didn't particularly care that we were doing this stuff, even though they were kind of tasked with making this closed down device. And so we had some people from the Android software teams as well as we were in, and we managed to get stuff working. Shell shock. So shell shock is a bug that is in Bash and was very famous like 4 years ago when it happened. It might have been 5 years. I think it was 4 years ago when it happened. Shell shock has a fancy name associated with it, shell shock. And everyone was hearing about shell shock and quite, will shell shock affect your system? It's gotten really common to now have a flashy website and a fancy name and a bunch of marketing efforts around a bug. Was it log? I mean, there was go to fail. The log for J1, there was some funny name to it, but I don't think it was log fail. But the shell shock, the issue is, okay, the way you define a function in SH, and you can use the function keyword, you don't have to. The way you I think the function keyword is actually a Bash edition. The more classic way of doing it was from KSH and everything that Bash was built on for copying. If you use the name of the function followed by open parenthesis, close parenthesis, you didn't provide parameters because the arguments would just kind of get passed in as like an array, and they didn't really have like it was just the parentheses just indicate this now function. Then you'd have squiggly braces. And within the squiggly braces, you'd have to have a sequence of commands. And you had to have at least one command. And if you're going to put it on one line like this, commands are terminated with new lines. And so you couldn't do, I put in this colon is a built-in the shell that does nothing, and then semicolon terminate the command followed by the squiggly brace. You could also use, you just put one new line in there because they would be like, that would be an empty command. But you couldn't just put a semicolon. I think that was the issue at the end. So I want to from one line. If I define a function called X. Shells also allow have their variables in a shell when you have y equals 3 and all these things. The variables default out of something called the environment. So when you run a program, there's these things called environment variables, and the environment variables are inherited. So if you have a program that has something in its environment and it runs another program, the environment variables that first program were given will be inherited by the second program. You can, as a program, you can remove something from the environment. You don't have to export those things. You can also then export things into the environment by adding them to the environment. And Bash, when you use a variable, it will first see if it has locally, but it will read it out of the environment. So you think about like really variables are kind of defaulted out of the environment. Variables in the environment and you update it. I think it will change in the environment, but that's not relevant to this. you can export something to the environment, use the export keyword. And so any variable, you've been working with a variable, then you say like export that variable, it will get exported to the environment. This is really convenient for when you're using in shell, you oftentimes will be like forking subshells, and then in subshells, you will kind of expect to have a lot of the same variables that your parent shell might have. And so some of those things are kind of inherited because you forked, but some of those things, if you ran like a script, you might want to like pass through. So they've got this feature, as you mentioned, export, and export supports exporting functions with export -f. When you export a function, it's not like Unix has a concept for functions in the environment. It just has a concept of name value pairs in the environment. So if you look at the environment, printenv will print out all of the parts of the environment. And I've got the -a too, but I know it's 2 lines long. It serializes the function by putting in open parenthesis, close parenthesis, space, squiggly brace as the first 4 characters, followed by a serialized representation of the abstract syntax tree of the function. So in this case, my colon, semicolon, in the canonical version of it, they didn't semicolons or anything in there, and they used a new line for the thing, and this is how it's serialized. Then, when a copy of bash runs, it goes through all the variables that have been sent in, and it checks if any of them begin with open parenthesis, close parenthesis, space, squiggly brace. And if it does, then it runs it as a function. And it really runs it. So if you put in the environment a variable x, whose value is open paren, close paren, space, open brace, some code, close brace, semicolon, another command like date, and you run bash, it takes the name of the variable, it concatenates it, once it finds the variable because it begins with open, close, space, open, and then it concatenates the name of the variable with that value, and it just runs it in bash. So that will actually run date. This was an issue when it was discovered as shell shock, because if, and this is big if a remote user, and potentially even an unauthenticated user, but somebody who should not have access to run anything on your computer, has control somehow over the values of the environment in that of a shell program, then they can run arbitrary code in it. And there are cases where people have built systems where environment variables include information from users, whether that environment variable includes a description of the full name of the user, and the full name of the user is the stereotypical version of like drop Bobby tables or whatever, but like it's open close space squealy brace, and then followed by some stuff. You might include a host name, and so if you can convince a DNS server to return something, and then people don't verify that what they got back is actually a valid host name. There are all sorts of opportunities to try to cause issues. And there's a really popular system, which is the Common Gateway Interface. Not that commonly used these days, but it was very widely deployed. Common Gateway Interface was a way for a web server to have programmatic behavior, and it did it by running an external program to be written in anything. Often, like Perl was very popular for a long time, but it could just be like a C program that you wrote, and it would take the HTTP headers that were passed in, and it would construct environment variables with special names. The HTTP underscore, the name of the environment variable in all capital letters with hyphens replaced with underscores, with the value whatever the user sent in. So there's like a one that was HTTP underscore user underscore agent for the user agent that was sent in, the name of the browser. And if the browser that you're running happens to be open parenthesis, close parenthesis, space, wiggly brace, space, colon, semicolon, close brace, semicolon, followed by an evil command, it would, and that CGI program then did anything with shell, it would run a program. And having a CGI program do something in shell also isn't too uncommon. So what ended up happening is that you'd in your program that you wrote, your CGI program, you as yourself would try to run something else. And a really common way of running something else is to use a function called system, and the program, or even if you use some of the more escapey versions of it, sometimes they'll still be backed by a shell. When you run system, what it does, it takes the argument you provide and it passes it as an argument to a shell. The default shell has typically been sh, but you can override that with like environment variables and things. And override the shell. Oh, and so every time you like system out to something, it would you'd have an opportunity to use shell shock. So actually, the one that software that I was running the Git. I mentioned actually in a previous class, we were like that like Git comes with a little web component that allows you to like browse all the files and repositories. It's called Git Web, and they also provide UI. Talk about Git a little bit. Git Web will shell out to Git for some things, and when it shells out to Git for some things, that's an opportunity to use shell shock. So they kind of scrambled, and a patch was put in. And actually, one of the patches that was put in ended up breaking some software that I'd written, and had the I determined. So I think that was in good company. That the way I was writing the software, the Google style guide told you to do it this way at Google, and so Brian Fox ended up having to come onto the bash mailing list and defend my software as you shouldn't just arbitrarily break J software, and you can fix this bug correctly without just kind of like pattern matching on these things. Because they kind of fixed, I was like particularly upset about it, and this is the next thing here, because they didn't actually fix the bug. So they fixed it. I don't know if they didn't fix it, but they didn't fix this. So if you set an environment variable, the name of the variable had a semicolon in it, it still just concatenated the name of the variable with the rest of it and ran it. And so they managed to, whatever patch they had, maybe it was like checking to see that the value of the variable parsed in a certain way. They verified that first one wouldn't be a bug, but that second one, we're like, no, this is a different bug. It's not a different bug. This is shell shock. You just didn't you need to actually think through what the bug is doing and then fix that issue. So this is actually, we're going to see this in a second in a much better way. When there's a bug that's been fixed, it might not really be fixed. So one thing that people will do when a bug has been fixed is to really stare at the code that was broken and stare at the fix. And sometimes they'll find the same bug, really. They'll find like another bug that's the same behavior. So shell shock. So Brian Fox, I just mentioned. Brian Fox is for your local Santa Barbara. Actually, I was first introduced to Brian by Murat, and I continue to work with Brian. He's part of Orchid. Brian wrote Bash a long time ago. So this on the left-hand side here is the photo of Brian that I think is still on Wikipedia. On the right-hand side are two photos that were taken with a prototype, very experimental digital camera that they were working on at the MIT AI lab back in like the mid-'80s, which was when Brian started working at the CRISPR Foundation as their first employee, and soon thereafter built Bench. And the late 80s, the internet didn't exist. So you're looking at, like, if you ask the question, is this a bug? Is it incorrect behavior that when you set the environment in a certain way and you run the program that it will run arbitrary things? I think it's an all clear cut that this even was a bug in Bash. If you were to go back to that time and you would try to describe this issue, somebody would stare at you like, if you, instead of setting that environment variable and running the program, you could just type the program you wanted to type. Because the way you'd set it, you'd have to be sitting at a computer in order to run these programs, and you could do whatever that user could do. If you could set the environment for the user, there's this assumption, right, that you are the user. And so it was arguably when they started building out CGI in the 90s that they introduced this issue by allowing a remote unauthenticated user halfway around the world to arbitrarily configure the environment of Bash without thinking, what does Bash do with that environment? Is there some limitation I have to put on these variables? Do we need to coordinate between these different software components? Regardless, Brian would get asked, because it was such a famous bug that played, like the New York Times was reporting on it, stuff like that. He got asked this question, another photo of Brian on UCSB campus. It was such a famous bug that he ended up winning a Pony Award for it. So I mentioned earlier the Pony Awards that GeoHot had won one of. The Pony Awards a category of bug which is the most overhyped bug. Like they've got all these categories that are like, oh yeah, it's like really complicated type of bug, or the best, and it feels a little bit like the Oscar, the best usage of remote code exploits and all sorts of things. And then they had the most overhyped bug, and that went to shell shock. And they asked the audience, the person who discovered the bug here. No, is anyone from Bash here? No. And then I really am like, I worked with the guy from Bash and hand him the award. And they were like, all right, then you're accepting the award. And that was like a big thing. They always had to have somebody come up and accept the award, even if it was kind of like tangentially related. But I was forced to go on stage and actually say something. And I had a good story to tell, which was that Brian had been asked by the New York Times, what were you thinking when you wrote this bug? In an interview Thursday, Mr. Fox, the Bash inventor, joked that his first reaction to the shell shock discovery was, my plan worked. As if he had injected this code into Bash in order to be a kind of like a little sleeper agent in your software for the past 30 years, waiting for somebody to finally take control of the world with shell shock. Yeah. Go to fail. So C as a language kind of sucks. For what it's worth, Go has this exact same kind of problem. I feel that while Rust doesn't have this exact issue, I feel that Rust is subject to the same issue. Languages that do not treat error handling as a background thought, that try to make it so that errors are something that you are explicitly working with, end up going down the path of weirdly, people rag on Java for making errors too automatic, but in fact, the real issue with Java was that it made errors too manual. You'd call functions that would throw various exceptions, you'd have to catch them, and you'd catch them wrong, just because you just had to catch them, even though it wasn't your job to catch them. You were writing software that had nothing to do with errors. The person whose job was to do with errors was 5 levels up in the call stack, but for whatever reason, every single function has to think about errors, and none of those people are qualified to think about errors. But C is just horribly bad. And to try to make it reasonable, there is a idiom that people use where you will check to see if an error happened. And if that error has happened, you will go to fail. And there will be like a region at the end of the function that will have a name like fail, and it will clean up the function. And so you'll initialize, actually, it would be nice to have the initialization here, wouldn't it? Error will be like initialized to 0. And you'll fall through. Like the idea is that at the end of this function, if it succeeds, you'll also end up in fail. But error will be success, and you'll return success. So you'll call each one of these functions, and you can kind of inline it even if you do it like this, like if error is equal to the thing, not equal to 0, go to fail. So it makes every line of code be an error check, which is horrible. But it interacts very poorly with the C feature of if statements not requiring block. And what happened here, as far as anyone could tell, kind of after the fact, looking at the revisions of the software that had this issue in it, somebody did, and we don't even have to know what the code did to see if there's something wrong with this. It kind of like it jumps out, right? Go to fail, go to fail. There was a merge conflict between two people who were developing the software when it had edited the same thing. Maybe somebody edited an argument, somebody had added a new line. And when they resolved the merge conflict, they were going really fast through tons of merge conflict, and then nobody noticed, because your eyes do kind of glaze over when you look at code like this, that they had introduced a second go-to fail. So the behavior here, though, is that you get into this function, you start doing work, the work's all succeeding, and then the error variable, which I really should have put the initialization, I don't know if I've thought of that before, is initialized to success, although actually it doesn't really, the previous function would have returned success. So actually that's a good point. It didn't actually have to be initialized as long as you got allocated right before its first use. But error will return success, didn't go to fail, and then it went to fail anyway, and you just skip whatever the function was doing. And in this case, this was kind of a critical function. This was the function that verified that SSL certificates were correct. So it would go in, and if the SSL certificate wasn't incorrect, it was supposed to return an error about the certificate had expired. The certificate was for the wrong common name. Certificate was for, and the specific check that they were doing then didn't get checked. And so I think what it was like for the chain. So you were able to like just keep going on the chain with like another certificate to the end of the certificate chain. And so you could provide like a certificate for Microsoft.com and then provide your certificate, and then didn't check to make certain that your certificate was actually signed by Microsoft. And then your certificate then was the one that was going to be used for all of the cryptography. And so this is go to fail. This is a very serious security exploit that makes it so that, I mean, if you're using iOS less than 7.0.6, you are just really screwed. Like anyone who's on your network can modify any of your, and man-in-the-middle attack to view any of your SSL encrypted traffic, allowing them to, by man-in-the-middle attack, see what you're doing on banks. Why would the second go to have the first fail returns? The first fail doesn't. So what happens is that, like, so this is early, like the actual, there's 3 dots there. The actual work of this function is going to happen below the 2 go to fails. So it like initializes a hash. It puts data into the hash function, which is going to work. It didn't even get around to finalizing the hash, much less using the hash. And then it went to fail. Like it just skipped to the body of the function. And so if the second go-to isn't in, that's the issue, right? The second go-to isn't in the if statement because the indentation isn't what matters in C. It's the structure, and the because C doesn't require the expression of the statement of an if statement to be a block. That's what allows, like, if that had otherwise been the case, it would have been much more awkward to have accidentally merge conflicted in a extra open brace to that, or like an extra close. Like it would have been more difficult to pull off. It still might have been possible because of the indentation. Like if you just injected the go to fail after the close brace, even though it was indented. So it's like it doesn't really. Then that's why some people are like, no, we should also verify that the white space is all correct, and that's why they're not just to have like auto formatting, which would have hidden the problem, but something more like Python, where the semantics would be different, and it would actually fail to compile if you had the white space. All sorts of interesting arguments people make about like ways of making this kind of programming more or less sane to do. But I at least for this issue, I personally very strongly blame the lack of either exception handling or error monads, and not whatever Rust is doing, because Rust doesn't have monads. Rust is sometimes people call it monadic error handling, but like they just have the data structure of a monad, but then they require you to manually work with the whole point of monads is to eliminate all of it. They don't. So this is go to fail. Poor man's error mode, yeah. So this was, I'm saying, that's right. I'm sitting here going, this is a very serious bug. This was a very serious bug. It got used. Like there are organizations that are constantly trying to get this level of access onto systems in order to be able to man the middle attack secure communication, because they've got privileged network locations all over the world. And the CIA, the FBI, just here in the United States, and I think I would have had a story though if I actually had like somebody very directly implicating the usage of go to fail, but yeah. All right, this is J-cases. So when the Android devices boot up, they go through this initialization sequence.
Jay?
Yeah.
Oh, hey, just the previous slide. So is this tied to the go to fail exploit?
I think I was just saying, I think I did say it out loud. Second, I don't really have a story that like directly connects anything with that, but like David, or is it this kind of bug is a very serious bug. I don't think I actually have evidence that go to fail was specifically used. Or I probably would have put it here. But I also did originally do this slide a long time ago and have not updated this section of these slides. So it's a serious bug though. Like, this is exactly what these 2 articles are saying people are trying to accomplish. So for Android devices, they have got they when they start up, they run through like there's like initialization scripts that get executed. And these initialization scripts that get executed, actually, this it might be the same file as the one that like lower in this file. It might have that console definition in it, or the console definitions in it. They've got like the services and things, but they've got like initial boot up stuff that happens, and these commands are just run before everything else. They're not like run again or anything. And a thing ends up happening with hardware manufacturing teams that are trying to debug an issue close to launch. I mean, software developers do the same kind of thing. So I think there's something that particularly ends up happening when you've got this issue where it's like the device works fine for a long time, and then it kind of stops working, and no one knows, because there's a lot of stuff that ran on the computer, ran on the device, what changed the behavior, but you've managed to figure out that there's now a folder that has the wrong permissions, and you have no clue what did it. And you're trying to get this device out, and there's like a person who's in charge of the initialization part, and you can just fix it by going to them, saying, every time the phone boots up, fix this issue. Mitigates the problem. If the extent to which the phone ever doesn't work, you reboot the phone, it works fine. Phone doesn't crash, is great. People don't lose their data. And so you end up shipping it. But like the person who's that's just so far removed from the person who could possibly have made the actual issue that you end up with stuff like, if you actually read through the Arcos G9 Android device in its script, it has a chmod 777, which means that everyone has access to the data misc SMB folder. Everybody has access to that folder, not just whatever user they set up that was supposed to have access to that folder. Everyone has access to that folder. And if you as a user can put something in that folder, then you now have the ability to potentially indirectly control these permissions. So the bug here was the user had access to either data misc SMB or data misc. You then put in that, describe it this way, but this is actually perfect, because the user clearly has access to data misc SMB. After data misc SMB happens, it touches a file in there, owns it to system, and then says everyone can read and write it. Not like execute or go to, but it's a normal file. So as a user, what you do, because you had booted the phone earlier, you have access to data misc SMB. You go in there and you remove that configuration file and replace it with a symlink to a device driver. Like you make it a symlink to a file in either /dev or /sys. You then reboot the phone, and when the phone boots up, it will touch that device, which is fine. You touch a device and it won't break the device. It then reowns the device to the system user. It might have been owned by a system user anyway. And then it says that device can now be accessed by everybody. And there are devices that, such as in particular one that JCase actually helped me use in order as part of the impactor exploit. There's a device driver that controls what happens when you do USB hot plugging. And so you like plug in a new USB device, remove a USB device, which in that same, the USB hot plug driver will end up occurring when you like plug the phone, I think even just taking to power and things, but if nothing else, you can always, if you got like a, the opposite direction, the USB on the go adapter, you can plug that into your thing in order to actually like literally plug a USB key into your phone. And then the hot plug driver allows you to specify a program that will get run when something gets plugged in. And so all we had to do was just drop down a file that's a symlink to the hot plug driver, reboot the phone, and now the hot plug driver can be used by anybody. You reconfigure the hot plug driver to run the evil payload, and then you do something that causes the hot plug driver to get tickled, which wasn't that hard without having to be on the go adapters, and then it would run. So JCase found this issue, which of course Google didn't put this on their phone. JCase found this chmod issue all over the ecosystem. That was like his thing. Something with a phone to jailbreak, and he just go check, oh, you do this one. And it was just a chmod issue over and over and over again. Google finally mitigated this by modifying the implementation of chmod and in the init system to not follow a symbol. And that way, no one could pause that concept of issue, but it didn't really solve. Like, people were still just playing whack-a-mole with these things. So there's still opportunities to, like, if you can get a file that you could like mess with, but like it's really dumb. But the mitigation for this was sad. Yeah. ADB backup. So the Android debug bridge is a protocol you use over USB in order to talk to the ADB daemon that runs on Android. And this is how, when you like want to install an application on the device, it works. There's over the like the USB gadget device driver protocol, you're able to just talk to you're able to, on the computer, open up that USB device, set up a connection, and then you're kind of, what happens on the Linux side is that gets mapped to a socket that's really being managed by this Android debug bridge daemon. And you can send it commands like install this program. That the Android debug bridge is running as a inconsequential user, for what it's worth. One of the features it supported, however, is doing backup and restore. And so you could ask it for a backup of a folder, and it would stream to you a tar file of the data owned by that app. You could also do a restore, and you would stream it a tar file, and you could extract that tar file to where that app was supposed to be. In this case, it's running as an inconsequential user, but it does need to be able to modify an app's files in order to be able to restore the data for an app. And so it had a way of being able to get permissions of an app for purposes of restore if the app supported restore. And I think at the time apps defaulted as supporting restore, but even if not, a lot of apps support restore, even like system apps. Tar files have a little header file, sorry, not header file, have a little header on each file. So a tar file, tape archive, the file format is just information about file, followed by file, followed by information about file, followed by file. The information about file includes the name of the file. It doesn't have a concept inherently of folders. It just happens to be that one of the things you can put in a tar file would be a file whose permission bits indicate that it would be created as a folder. It does then have to check, different system calls in there. But like tar files don't like have this file is inside of this folder. It just has in your tar file, as you extract it, might have entries in there that represent extracting a folder. Each file has the complete path from where you are to the file you are extracting. So if you have a folder in there, the next and then a file that's in the folder, the name of the folder is going to be repeated / the file. If you don't have to have the folders in there, like what will happen, some implementations might detect that, like, oh, you're extracting to a folder that doesn't exist. Maybe the user was supposed to give it to me. There might even be like some command line arguments to control that behavior. But you can also end up with versions of it that just refuse to extract. Like, they'll just go to what they're doing is they read the header, they open the file of that name, and they start writing to it. And so if the folder didn't exist and it wasn't part of the tar file, then it would just fail when it gets to that point of the tar file. It would go to open the file, and it wouldn't be able to open the file because it's opening a file in a folder that's not there. If all it's doing is it's just taking that from the header file, it just takes the name of the file and passes it to the open system call in order to open a file, what's to prevent you from using, whether it be an absolute path, let's say? Well, it's easy to check for an absolute path because absolute paths begin with slash. So like if your tar file is like opening files that are supposed to be sub files of an app, and then one of the files that you open is like /dev/ my file system or something, we can refuse that because it's slash. You have to check for that though. You also need to check for relative paths that are relative parent paths. So the issue here was that you could just put .. / in the beginning of your file that you're restoring as you're streaming back up to the device. And that would escape the app folder, out of the folder of all of the app folders, and out of the data folder back up to the root directory. And then you could just slash down into whatever you wanted. And if you could restore an app with sufficiently high permissions that the debug bridge's backup restore mechanism would be forced to take on something akin to root in order to write to its files anyway, you now could, as root, write to anything on the system. So this ADB backup, this class of attacks are called traversal attacks, lets you get an arbitrary file write primitive, which might be sufficient to do what you want, or you might have to combine it with something else. Like if maybe I only have the ability to back up and restore to something that is owned by the system user, and for whatever reason, the system user is allowed to access a file because something in the init script configured it to allow it to do it, even when it made no sense. A file that I had control over, allowing me to like redirect the system user to get access to a device driver, and then I can use an ADB backup restore in order to restore data into that device driver. You can chain these issues together in order to build more complicated attacks. So talking about the Android debug bridge, there's this issue, rage against the cage. So when the Android debug bridge begins, I mentioned it runs as an inconsequential user, but it's like a USB device driver on the other side. An inconsequential user can't just become a USB device driver. So there's always this like bootstrapping issue. You'll have some kind of program that like is a dangerous program to execute at all, that wants to not be dangerous by not having any privileges, but it needs to at least temporarily, momentarily have enough privileges to run and set itself up. And so it's a rather common paradigm. You will run a program as root. It will do its setup work, opening a privileged port, accessing a device driver. It will get all of its file descriptors ready, and then it will drop privileges by running the set UID and set GID functions. Set UID sets your user, and set GID sets your group in order to switch to some inconsequential user. Does anyone see the bug in this? I hear Murat has a train behind him. That is not the bug. What if secure is false? If secure is false, then it will run as the privileged user, and that's actually fine. So there's a command that you can run with ADB, which is ADB root, which will request that the debug bridge restart itself as root. And you might have the permission to do that. You probably are not supposed to, but you might. On debug devices, like when the Android G1 was that first Android device, on the Android ADP1, the Android development platform device, they think they allowed you to do ADB root in order to get root on that device. It cost an arm and a leg versus a normal Android device. And of course, you couldn't then target it as a market for something like software that required root or anything. But that is not the issue. It is relevant. That's only relevant to our X, but does not. The bug does not include that line. So, does anyone remember? We looked at this a little bit ago. How do you check for errors in C? compile it. That's how you check for compile errors. Actually, the way you check for errors in C is you're going to have to manually look to see if there's an error code, and then potentially go to fail. You might not structure it to go to fail. You might check the error code and then in that location undo things. But you need to, the way you check for errors, if something fails, is you have to do it, you have to manually look for the error. So the issue here is set GID should fail. Set UID can fail. And there's nothing checking the error. So it's just going to keep going. And the question then is just, can we make it, the root user, as whatever reason, like even it's another reuse, the shell user has, for whatever reason, a quota that only so many shells can be run. As if, like, somebody's going to go in and fork bomb their own phone over ADB, and they want to prevent that from happening. So Rage Against the Cage is a bug where you fork bomb your phone connecting over ADB, and the rage against the cage is, I think, a very literal metaphor here of you run a fork bomb that will fizzle. Fork bomb is where you have a program that forks 2 copies of itself, and it tries to use up all the resources on the system, but it's going to fail because it's going to run into a process quota, and it's going to use up all the processes the shell user is going to reveal out. And then you ask the ADB daemon to restart. And the ADB daemon restarts, and when it shuts down, there's now one open process available, and the ADB and the fork bomb will take control of it. So now there are no processes left. And then it starts running, and it will go through, and it will attempt to become the shell user, and the set GID function will return. Actually, GID might work, but set UID is not going to work. Set GID is going to be like, no, sorry, you're already running too many programs as shell, even though you're rooked. And so one thing that came out of this was I think the kernel, the upstream Linux kernel even decided that it's probably the wrong behavior for set UID to not allow the god of the computer to become any of the normal mortals under any circumstance. Like if your quota does not allow you to run 5 programs and root is calling set UID in order to become that user, root should be allowed to become that user, even though it will become a 6th process. But the core issue here is just you have to check errors. And if you don't check errors, people are going to be able to take advantage and force error conditions on you. And so you should be very skeptical of any software that does not check an error. And it's like the lack of this error check is dire because it allowed for the person to get complete control over the entire phone over USB, as opposed to merely some local, bug or something. The Verizon Droid 2.0 bootloader. So you've got an Android firmware image, and you're going to load it onto, which is happen to be a zip file, and you're going to load it onto the, you're going to give it to the bootloader in order to extract all the different flash images of the like the root file system, but also the kernel, and they've got different flash locations. That the zip files that you gave it had a footer with a signature on it. Zip files suck as a file format. The zip files are like tar files, where you've got the header for the file, contents of file, header for file, contents of file, yada yada yada. But that's really slow. It's really slow because, like, if you want to find an arbitrary file in a very large tar file, you have to scan through the whole file. So zip adds, they don't take away the header file concept. So if anyone ever tells you you can't stream a zip file, they're wrong. You can stream a zip. They add, however, to the end of the zip file an index, which is the data structure that allows you to rapidly find other parts of the file. This is not the bad part really yet. This is a problem, it's a serious problem to see, but not here. This is a serious problem we're about to experience in a couple slides from now. But this isn't, what sucks about it is, what's just ridiculous about it as a file format, is at the very end of the file then is the footer. And the footer tells you how to find the index, but the footer is allowed to have a comment on it, like just some extra data about, and if you're parsing the file and you begin, you should have the footer be the last thing in the file. And then the thing right before that should be any extra data you injected. And the footer should tell you how much data is there. But they put the data after the footer. So somehow the footer, this is where the footer is, has instructions in it, like to tell you how long the actual footer is. So if you want to find the end of content directory or whatever, you need to actually go to the end of the file and just keep scanning backwards looking for the footer. And so that's what they're doing here, is that the footer begins with OX50, OX4B, OX05, OX06. And they're scanning to find the end of central, I think it's not address, end of central directory. Does anyone see the bug in this software? Based on our previous slide, you might expect that the bug in the software is something where if you just kind of think about what you're supposed to do from C, or like, you kind of matching the code, like the previous bug didn't actually require you to understand the semantics of the functions, other than the things can often fail, and you probably need to check every single freaking function like you didn't check for errors. There's an error here. It should be very obvious, but
I plus
I
3.
think that it might not be. That's correct. So Marat got it. So it's like checking I plus 1, I plus 2, and then it checks I plus 1 again, which for what it's worth is literally never going to work, because I plus 1 cannot simultaneously be equal to 4B equals 6. So actually, an automated check might have detected this. There are sometimes warnings you can turn on compilers that look for tautological errors. I'm sorry, that look for tautological conditions. And so here it is a tautology that this if statement is false. Therefore, why did you type all of this code into this if statement in order to give me a complicated tautology that is false? And so sometimes compilers can check these things, but they might have typed I plus 4 instead of I plus 1. So you can't be guaranteed that that kind of thing will be detected. Instead of doing it like this, I might have tried to do like a num compare. So at least you're looking at like over the case of like 4 characters, and you had them all in sequence and inside of a buffer that came after it. But such is life when you're dealing with like these little things. You sometimes have twiddly bits that you all have to check. And it's not even like you went past the end of a buffer. It's not like you ended up in not unverified. Oh no, what is the term we were talking about when I was going over C++ stuff about like where you got behavior that's different depending on like that, where like you don't even like, because you like broken the model of the computer because you'd access memory that was fundamentally not part of the undefined. You didn't use any undefined behavior here. This is just a logic bug that will make this not work correctly. So what you were able to do from this, for what it's worth, they were verifying that so they always put at the end of the file in that comment block is where they put the signature for the file to verify that the file was correct. And they just wanted to verify that the signature for the file and the whole footer, they figure out where they wanted to verify that the footer didn't really contain a footer inside of it before passing it off to the thing that extracted everything. And they failed to check that correctly. And then the idea was that you would put in your comment block a internal, like an extra footer that was inside of your comment block. And the parser that was at this layer actually succeeded in finding the correct footer and was checking to verify that the footer didn't contain a footer. But then, like the other version of zip that they were using was just really dumb. It was just extracting it. And so they were able to. That's right. They were able to verify signature. Oh, I'm sorry. It's even cooler. There's one. I'm sorry. It's not just that they put a footer in the comment. They put a whole zip file in the comment. So they took the valid zip file with the valid signature. They put the whole thing in the comment. And then their signature verifier was actually verifying that that there was finding that sub file, verifying it, and then the failing to have any sanity checks that like the footers didn't contain file. Yeah, so this was the bug that allowed us to jailbreak the Verizon Droid, and it's like a typo, a one-character typo. All right, so Gingerbreak was the jailbreak for Android 2.3. And so there's a daemon, a volume management daemon, that accepted commands with relation to mounting and unmounting file systems. I think this was particularly used by SD cards and external USB that would be plugged in and taken out. And it had a data structure it was maintaining for the partitions that it was managing, and it has this array in it, m-part minors, which is of size max partitions. So there are 4 max partitions. You have 4 partitions. M-part minors, that is an array of 4 elements. The code that accepted the command receives something that the event object is a little key value map that gives you back a string. So when you pass in commands, you'd pass in like the major is, and you pass a string, minor some string, part end is some string. And then EVT find param will give you return back the string for that parameter. And so it's parsing out the major, the minor, the partition number, which gets back as a string, because the partition number was verifying if it's optional, then it would replace it with 1 because it would go through and access if the part number is if mdisk num parts, one of the variables here was the mdisk num parts, the number of partitions you have. If the part number, partition number you're asking for is greater than the number of partitions you have, it will up you to the number of partitions you have. By setting, I'm sorry, actually it's even more awkward than it sets the number of partitions to the partition number. So does anyone see a bug with this? Did it just increase the partition limit? It did. So I was actually kind of pointed at this by reading it out and noticing the issue as I was reading it. But yeah, it just increased the number of partitions. Is that not okay? Yeah, the fun part of this is actually the next slide. Actually, I kind of learned that if I don't give this one away.
The last assignment in this line, it's unsafe, isn't it?
Yeah. So the actual bug is the next line, right? And so part of the reason I actually kind of learned that if I don't give this slide away, people start guessing later slides. So they fixed this. Great. If the partition number is greater than max partitions, greater than or equal to max partitions, it logs an error. Instead of, and actually I think slog-e will like actually fail, like it's a macro that may go to fail or something. And then otherwise it does the assignment. Actually, that's a good point. The assignment's in here. So it just says it's going to log an error instead of doing the assignment. So great. Here is the updated code. What is now wrong with this code? So I'm going to say, like, they made it worse. If you find issues in this, but the issue here is that they actually made it worse somehow. What did they do wrong? The partition number is 0. That is wrong. But that was an issue before. What if the partition number is 4? So if the partition number is 4, the partition number is supposed to be a number between 1 and 4. And if the partition number is 4, now it logs an error. It doesn't even work. Like they fixed this bug of overflowing of too high partition numbers by actually breaking the ability for the function to even work correctly on the 4th partition. So they fixed it. Fix an offset 1 bug that makes partition 4 unusable. And so instead of using greater than or equal to, they use greater than. Here's the code again. What's wrong with it? Vincent already told us. What if the partition number is 0? Okay, so if the partition number is 0, 0 is not greater than the number of matched partitions. 0 minus 1 is now negative. That's not a valid thing. So it's just, and it's even 0. You're allowed to pass in, this is where it gets really fun, arbitrarily large negative number, because it just takes the string, passes A to I. And so instead of it just being 0, you could pass in negative, 500,000. And so if you know where something is memory that you're trying to overwrite, you can set it to the minor, you can just pass in the part n as an offset back through memory and then overwrite it to minor. This is horrifyingly broken code that they just couldn't fix. They're just sitting playing whack-a-mole on it, and they just keep not fixing the bug. And honestly, I see like organizations that are sitting around and they spend a lot of time and effort on regression testing and unit testing in order to try to verify that you aren't you're handling all sorts of edge cases, and that like and I can't help but feel every time I deal with one of those, it's like, yeah, if you have a big, a billion monkeys in a barrel that are all just like putting no thought at all into the things they're doing and are just arbitrarily throwing in conditionals and attempts at fixing a bug without even asking for a couple seconds, what am I actually doing here? What might be a more fundamental fix for these things? And in this case, if you're going to sit around in this is C++, if you're going to sit around in C++, maybe you should be using vectors with .at instead of using this sort of thing. If you can't trust anybody, don't give them arrays. But like, it's just, I just find it all so depressing. And there's so many bugs in all the software. Okay. Android 4.0, Mempo Dipper. Jason Dunnenfeld, the guy who now, this was not the case yet, but now is very famous for having made WireGuard. So if you've heard of the WireGuard VPN protocol, that is Jason Dunnenfeld's project. Jason Dunnenfeld found a bug in the kernel that he called Mempo Dipper. He published a blog post about it, and he did not provide an exploit. He wanted to tell the world about the bug. He wanted to explain what was wrong, like what had gone on with it. He had built an exploit for the bug, but he didn't want to, enable an attacker to actually mess with somebody. He didn't, building exploits hard. It might take Jay 2 hours to write an exploit for the bug, which is how long it took me in order to exploit the bug. So I read the blog post and I was like, this is going to affect Android. We could use this for an Android jailbreak. And so 2 hours later, I successfully cobbled together an exploit from it. And Jason learned a very valuable lesson, which is that you cannot tell somebody that a bug exists without enabling them to use the bug. So this bug is, and actually, if you search around for it, my implementation is called Mempo Droid. This bug is, there is Unix-like systems, we like to think of everything as a file. One of the things that we would like to claim is a file is memory itself. You can memory map things into memory, so files become memory, but your memory as an address space.
Portakal, hemen yapıyorum.
Murat, your speaker, you're not using it. Cross never now. So your address space itself, a file, is represented by a device driver called devmem. Devmem is a file then that you can fopen. You can seek into it and you can read from it. And if you seek into it in an offset and read from it, you are actually reading from your own RAM. There are various reasons why this is useful, but what is kind of important is to make certain that you can't like open somebody else's devmem somehow in order to get access to some other program's dev memory. So when they have a check in the file, in the callback for when you try to write to a devmem device, which checks that you have permission. Okay, so you have to have the same user. But the important one here is if file's private data is not equal to the current self-execution ID, then, or really self-exec ID, go to not in. By the way, these go-to things are kind of like go-to fails. Right? And it will happen if really explain it for you. If you have like more complicated unwinding logic where it's like as you build up more things, you need to unwind all of the things you built. And like if there's an error earlier on, you don't want to unwind things you haven't built yet. There you'll have like multiple fail targets, and then like as you build out this out of your function, you'll have to go to fail shallower and shallower into your undo stack. But or higher and higher into your undo stack might be a better way of putting it. This check, private data, self-exec ID. So we're going to look at where private data comes from, where self-exec ID, and figure out what this means. So when you open a memory device, the private data is set to the current self-exec ID. So now you can think of like the type, like the semantic type of what we're comparing now makes sense. The private ID is a self-exec ID. We're comparing the self-exec ID from when the device was opened to the person who's using the file, and we're verifying it in the same self-exec ID. So what is a self-exec ID? Every time you call exec, it increments a number. So the thing you want to avoid is that, like, I'm going to open a file, devmin, and I'm going to assign it to be one of my file descriptors. And then I'm going to exec another program. And when you exec a program, you replace your current program with the new program, but it inherits the environment, all of its file descriptors, and also it's actually the same process identifier, by the way. So you can't like compare process identifiers or anything. What you're doing is you're just kind of gutting your program and giving it the new one. The memory space of the program will be replaced. You will get a new memory address space, and that will then have a will have the new, like the program you've executed mapped into memory, but all of the file descriptors are going to be the same. So what this is doing is every time you exec, it's making certain that the previous program that was in my process that's giving me all my file descriptors, or if I fork a process and like I'm actually like a child process, either way, like the child's going to have to like exec in order to like get it to become something different. I want to make certain that every time I call exec, I am divorcing myself from previous memory instances that I may have had around. There are like two issues with this. The first one of which really is self-exec ID, and can I figure out a way to kind of overflow it? But that's actually not the issue here. The issue is that when there's another system, kind of like with the shell shock thing, where if there's somebody else built something under an assumption and that you violate with your new code, who's really at fault for the issue? There's another system on Unix, which is called Unix domain sockets, which is a way of doing inter-process communication that allows you to not only send data, but allows you to pass a file descriptor from one program to another program. And so you're able to open up memory devices in one program that have certain self-exec IDs and then ship them to other programs whose self-exec IDs are earlier in time that you control, and then wind them forward. So the actual issue here, now we're actually going to get to see, as I show you this exploit, this is one that I did. You can actually kind of see how an exploit may come together. And so what I just said will make more sense as you see the thing also. So there's a program that is called Run As that comes on Android that is setuid root. And when you run it, it verifies you tell it, as an app, I want to run something. And it verifies that the app that you're running it as allowed you to do this. However it does that is actually kind of irrelevant. The assumption is it doesn't. It doesn't allow you to do this. It also is verifying that you called it as shell or root, which is good for us because we are shell and root. And the first thing, in order to check to see whether you're allowed to do this, again, you're not going to be allowed to do this, is it calls get package info. And so you pass in the name of the package as one of the arguments, and it's going to look up that package, get the package info, and then somehow do the permission check somehow. Whenever it fails, it calls a function called parent, which will print something to the screen with the current program name and call exit, which will quit the program. And it's a C function. It's a C function in the C standard library. There's another one which is underscore exit, which is the system call. When you call underscore exit, it will like immediately terminate the program. Exit will actually like carefully turn on the program. These are functions. So what it's worth, the thing I'm going to do with this exit thing is kind of relevant for both. what I did is I constructed a Unix domain socket between a program. So this is a program now that I've written. This is now our program. This is our attack. Our program is going to construct Unix domain socket. So now there are two programs, one of which is the child and one of which is the parent. The child has a process ID that is one greater than the parent. Well, the process ID is probably greater than the parent. Actually, that's actually kind of weird. It has a process ID that's different from the parent, but it hasn't yet called, neither have called exec. So they actually currently both have the same self-exec ID. They just have different process IDs. They also now have a Unix domain socket that lets them communicate between each other. What we're going to do is we're going to have the child. I think it's the child side we're going to do this on. We're going to actually verify the child calls parent. Yeah, the child is going to call exec, and it's going to run the attack. And I just have a little variable to make it so it's one binary. I have a little variable there, which is that little password xc-jm. If you run the program with that as its program name, it assumes it's part of the child. It's not running the attack. So the parent forked the child called exec. So the child is now running with a self-exec ID, one greater than the parent. And then what is the child going to do? The child is going to open devmem, and all the rest of this code is it's going to send a copy of its devmem descriptor to the parent. So now the parent has a devmem descriptor whose self-exec ID is one greater than the parent. And the parent is going to call run as, which using exec, which means that the parent self-exec ID will now be +1, which means that the parent is now going to cause run as to inherit a file descriptor to a copy of devmem whose self-exec ID is the same as the running copy of run as. When we did this, I went back. I'm looking at the child code. I call no, actually, it is. I'm sorry, I shouldn't have gone. It is this line here. So the code in the parent then, when it runs run as, called dupe2, and it this is the code that I wrote, called dupe2, and sets the file descriptor number 2. So dupe2 duplicates a file descriptor to something, like that's like, the number, not really the number 2, but it's like, like it is a number 2 because it's a version of dupe that takes 2 arguments. So like it's actually like, I shouldn't visit, but like I find way more, it's like it dupes to a location. And so the dupe2 is setting file descriptor 2. What is file descriptor 2? File descriptor 2 is the standard error. So anytime the run as program attempts to print an error, which is what it did in its panic routine, it will now write it to devmem. We then call run as and pass as its argument for the package name. We're going to pass in an exploit payload. So if you look back at the code for what run as did, is it called get package info on the package name. That package is not going to exist because it's like a weird exploit. So it's going to call panic, package quotation mark, %s is unknown. Panic is going to take that package name that we tried with the exploit in it, and it's going to try to print it to standard error. So it's going to overwrite something in its own running memory with package open quotation mark, the name of the package, which we controlled and we made it horrible. It's going to overwrite part of its own memory with it. So going back then to the parent code here, it calls exec on the parent error. And so then here's what our exploit looks like. Our exploit is machine code that needs to, very carefully, by the way, not have any null bytes in it, because C strings, including arguments, are null terminated. So there's actually, I wanted a 0 in here, couldn't have a 0, so I move into R5 the number 1, and then I subtract from register 5 the number 1 so that I get 0. That's how I get a 0, because otherwise it would be, if you move 0 into R5, it'd be 2500, which is 0, which would be null terminated, would be bad. So we then you have to take into account that there are 17 characters before this exploit, which will be RUN-AS : package space the quotation mark. So we have an offset in memory that we're going to want to overwrite with this payload. We're going to subtract 17 from it, and then we're going to else seek our dev mem before we pass it in. We should have probably a ... somewhere. I guess that's at the ... online. It is there. I just have these extra ... The second ... on the fourth line of code there is where all this kind of goes. We're going to else seek into dev mem to that location. So what is it? Pop R0, R1, R4, R5 is what I figured out. The easiest thing I could convince people to figure out for me was to give me the address of the function exit and the location in memory of a call to set resgid. And like later on, I do. After it does all its permission checks and various things, it ensures that we change real effective saved UI IDs at the same time to avoid nasty surprises. It calls set resgid, and I determined that it was highly preserved across compilers and across all the different Android vendors that I was finding. They all ended up with, luckily, register 5 was the register that info.uid was stored in. And so if you could just jump to the call to set resgid from panic by it's kind of like a long cross-programming sort of jump. And so what I'm doing there is I'm kind of like returning into this this other layer part of the function. So like you called panic, so the implementation of it, by the way. Panic called exit, panic jumps to exit, and then I have that return down the stack to this location as if you had called it from this function. And really, the exploit here was, again, it was just put 0 in R5 was the big thing. And then before that, we had to there was extra stuff on the stack, so let's just get rid of it. And then we have to get the address that we're jumping to, and then you branch to it. So we're just returning down the stack to that location by getting everything off the stack, putting 0 in R5, and then jumping to that location. And then that will, actually, here's the code for what that said resgid. It's going to always be R5 that you would load into there and called set resgid. So you just had to jump to that location. And then that would allow 0 is root. So then you'd set resgid, it's set real and effective. Oh wow, it's set real effective. The S has got to be another modifier, it's not another set. No, but you're setting all 3 of these kinds of GIDs to the thing. So you're gonna make yourself root. And that's the attack. All right. Master key is another story of somebody sort of presenting a bug. So in this case, it was Jeff Forrestal, who, I'm sorry, I have not very good lungs, and I do not talk often enough over the last 2 years, and it's not so. Oh, wait, Vincent says, wait a sec, what's up? How did you get the self-executive to match again? I had my attack forked a child, which called exec on itself. So its self-exec ID is +1. And then it sent a file descriptor back to its parent, who then called exec on the runads. And so the child's copy of self-exec ID, which was +1, is now the same as the parent's self-exec ID when it execs the thing. The question was just, how do you, from the future, pass a file descriptor back to this copy? And now it's just the Unix domain sockets that we used. So Jeff Forrestal is the person, he's described, I haven't actually done the reference checks on this or anything, but the real reason is to do this wave around. But when you hear this concept of responsible disclosure, which for what it's worth, in some of the narratives I give, I go into more depth on this sort of thing, but I don't think I do in this one. I don't really believe in responsible disclosure. I think it's like a responsible disclosure is where Microsoft tells you shouldn't tell the world that they're a danger. You should tell us so that we can fix the thing before you tell the world. If you really, really believed in that, it'd be very difficult for us to work on jailbreak, because we zero-day exploit things and tell the world. We do what's called simultaneous disclosure, where we tell everybody in the world at the same time so that people, the attackers and the protectors and everyone are able to work on it. Now, we do something that's kind of extra, where the gray hat, I think, really starts to come in, where it's like we actually do hoard bugs, and then we work on building exploits for them. And so we know about things that are damaging to the people that we will like for various reasons. And there's all sorts of interesting ethical issues that come up in the extended director's cut of this thing that has hundreds of slides. We talk about all the various interesting ethics of it in a minute. Good, some different point or something. This is like an after discussion, or maybe later today or something. But the important thing here is that it's really useful to point out that Jeff is the person who came up with, I think, the first responsible disclosure policy. He discloses bugs very responsibly. He disclosed this master key exploit that he found to Google, and then he he decided he wanted to give a talk at DEF CON. Actually, it was even better than that. It was a talk at Black Hat. I think he probably also gave a talk at DEF CON. Well, people go to Black Hat, they get expensive to go to Black Hat. Black Hat's expensive. And now you're in Vegas anyway, you spend an extra 2 days in Vegas and go to DEF CON. And Black Hat also pays all of its speakers, and then but doesn't really mind if there's similar content that's done at DEF CON days later. So DEF CON, so he goes to the event, and I'm reading the abstract for the talk. All it says is that he's found a bug that allows him to sign, as if he has a master key, to sign any application as any developer. So you can take any, and I think he may have even gone a little further and just kind of said that, like, given an existing signed program, he can make a program with any contents that's signed as the same developer as the first program. And so I was like, I want that bug. I can use that for a jailbreak. I want that bug. And so I spent the evening, again, it was like a couple hours, digging through the code of the signature stuff. So I'm the iOS jailbreaking stuff. I'm the signature guy. I'm the person who does all the code sign, alternative utilities, and all that stuff. And so this is my kind of thing. So I'm kind of like looking through all the code, the signature stuff, and I find, get this, not one, but 2 bugs that would let me do the thing that Jeff said he could do. And actually, it was kind of devastating because now I didn't know what to do. Now I can't, like, if I build a tool, I don't want to waste a second bug. Maybe Jeff didn't find something. You're still off mute.
Looks different.
Hold up.
Maybe it's the answer.
Baby ants. No.
It's not answered.
Sorry, guys.
Okay, he's now off. Okay. Jeff Forrestal. Oh, I now found 2 bugs, and I really didn't like just going to release one at Black. I don't want to burn a second one. I want to burn Jeff's one. So now I had to go start digging. I was like, going the underground, talk to JK, so talk to people like, hey, have you heard any rumors of a bug? Like, I'm trying to like root out which of these bugs is this bug, because I want to build a jailbreak out of it. I ended up getting, I think, good confirmation of like which one it was he had done, that he had found. So I should remember the time on this. This part doesn't matter as much, but I think it makes it more interesting if I didn't know it. But I released my tool, and then after I released my tool with the giant write-up of how the bug works, another person came out with a bug. So it turns out that there were 3 bugs for this issue, for the same issue. And I later talked to Jeff Forrestal, and Jeff had found the 3rd one and not my second one or something, but like we all found like different subsets of these bugs, and like we didn't all, no one of us found all 3 of the bugs. I think is how it worked out. But I ended up before his talk, I then, just based on the idea that that's like somebody's like, there's gold in them there, I went up and I found it. And because if you just know, like, that's already way better than knowing gold exists as a theoretical concept, which is already better than just hoping that something valuable exists. So I built tooling for it that worked really cleanly to do the whole thing. So the master key bug is the simplest version of it, which I do go through the variants here because they're relatively easy. Java does not have unsigned types, but the zip file format is unsigned. So you call it short, and it returns back to you a 2-byte number that's supposed to be between 0 and 65,535. And it in fact returns back, which is even the first one. one second. M entry. Oh, that's even the first bucket. There's so many. This one poor slide contains. Okay, so the first one was that Java uses zip entry here is being allocated, is being put into a linked hash map. A linked hash map is a hash table that where every hash bucket contains a linked list of all the elements. If you put a second entry into a linked hash map, the most efficient implementation, which I'm presuming we're doing here based on what I can't remember the other things, is to put it at the beginning. You can add something to a linked list at the beginning in constant time. Going to the end would require iterating to the end of the list to find it. So when you add something to a linked hash map and you add something again that has the same key, it will get added before it in the linked list because it will get hashed to the same bucket. It will get put in the same bucket. It will be put earlier in the list. Now, when somebody's then later on going through the list looking for an entry by name, they will find the second one first. However, and the way that they then parsed it is they went through and they in Java would verify by going through all of the entries in the file that they had put into the linked hash map. They would check the certificate of each one of them. But the thing is that one of the key files, the actual code segment, wasn't being loaded by Java. It was being loaded by the C Java runtime that they had. And so we've got a C implementation of a hash table here, which is implemented in a somewhat stereotypical, the add to hash function is a somewhat stereotypical collision avoidance hash thing, where it's like you hash to a location, you see it, you try to put it there, but there's already something in the bucket, you just go to the next bucket. And so you end up putting things, you just find the next free bucket and you put it there. And so instead of there being like the hash buckets that when you start running low on hash buckets, you're going to resize the hash bucket larger. It's not like in the linked list thing where you can store an arbitrary number of things just at lower speed resolution because you can start digging through linked lists. With this kind of hash table, you actually have like a max capacity that the hash table can even store. But what happens if you go to a location, then you skip the next bucket, next bucket, and then you like go later to go look, you're going to go to the first entry and you're going to find the first one you put in, not the second one. So the implementation of pulling classes.dex out of the file here finds the first classes.dex in the zip file, whereas the implementation in Java found the implementation in Java found the second entry of class.dex. So what you only had to do is construct the classes.dex file that contained, here's the implementation of it. So it of the C version that does the skipping. So all you had to do is take somebody's existing program that's already signed and then add a second code, like a second classes.dex same zip file with your code. And I'm sorry. Yeah, we just add a second one, but it's added first. You added it, I guess, earlier. And then what would happen is that the signature checking code written in Java would verify the second one, and the C code would pull out the first one. And so it would verify the wrong thing and let you use any version you wanted. There is, it was interesting. This was C code. Now we're actually looking at, so here they actually had another copy of this code for whatever reason for loading the manifest files, which is actually using C++. What was interesting about this, and the reason why this became relevant, is that you want to also be able to like change name of the program and change. And actually, the attack that I ended up having was I combined this together with, I think, a backup restore exploit and JCase's USB hot plug thing. And so what I did is I modified a manifest to make it back upable. And then it would like verify as the wrong program and then load up the wrong manifest. And here's a package ID, and I set its shared. I set it to the system user so that it would have full permissions. here's a cute way of getting the zip tooling won't let you put the same file in the thing twice. And so you pull a zip file, unzip it, and then you're unzipping into your I'm unzipping. CD settings. Oh, I see. The zip tooling allows you to add files to an existing zip file. So what you're going to do is you're going to take your attack file and you're going to rename Android manifest to exploit manifest by doing a low-level byte-wise search and replace on the zip file in order to replace the file name from Android to exploit. And then you're going to add all of the files from the valid file, such as in this case, just the settings app, add all the valid ones from the settings app into the thing, and then rename exploit manifest back to Android manifest. And so that way you will be the first entry, manifest entry, instead of the all of the second entries will all be the valid ones. It's all really convinced this weird. I had forgotten that I did this. Then I use run as in order to pull it off, because by stealing the manifest from system app, so the system app was signed by the phone, the system app, the settings app was always there. So then I'm able to take the settings system app, steal its signature, and then change my package ID to a different package ID with the same system user identifier. I'm then able to use run as in order to run as the system user, because you don't get to run as root, you only get to run as system user. And here's where I made it debuggable, which allowed me to connect in over the GDB protocol, because I re-implemented a ton of protocols in order to change things. So then there's another bug here. So, and this is actually how we tied it together with the other. When people use so there's a MKTemp is it's in here somewhere, right? You must use them. No, they don't use MKTemp here. That's actually even worse. So there's a directory on the system which stores properties that are that are persisted across reboots of the phone, and the file is just essentially like a name value of the file name is the name, then the value is the contents of the file. And when you call set property, what it does is it creates a new file .temp and it writes it into there, and then it copies from that file. So it renames that file over the file that might already be there. This allows you, because it's a predictable file name in a folder that is run as root, it allows you to change properties. And if you can get a symlink into there, you can set a property, you can make .temp a symlink to something else, and then set a property through that .temp and actually break some other device driver. And the fix for this is, the first is to use MKSTEMP, which is to make a secure temporary file, where it takes a pattern to the file and it generates a new file. And it doesn't just, there's a thing called MKTemp where it just makes a new file and tells you the new file name that it made. MKSTemp makes the new file name and atomically hands you back the file descriptor to the correct file. So there's no issue of a race condition where you call MKTemp, it creates a file, somebody else detects that file is there, quickly deletes the file, replaces it with a symbol. MKSTemp creates the file, certain that it's unique, and returns to you the file descriptor of the file that you put in. So the file that you created. And it's very important if you need temporary files that you use MKSTemp. Here's then the one where it's the same topic. The file format of zip is unsigned, as I was mentioning, and then you can call read short, and it will return back a signed number in Java between negative 32,768 and positive 32,767. And when you then, this is literally the code that we found. It was called local extra len or whatever. They would get this number, and it would be negative. And it's the fact that the person who wrote this didn't even seem to understand what this was for, because they called the variable local extra len or whatever, makes me so sad. And so here's just a little diagram of what you're able to do then is have it so that the extra data is almost 64 kilobytes, but you make it so that it's slightly negative. And it turns out the dex files begin with DEX, and the classes.dex file ends with DEX. So if the file name and the data overlap by 3 characters, so if you make the local extra len or whatever -3, you're able to make it so that the data pulls back out the last 3 letters of the name and overrides it. But you could do ridiculous things like going back a full 32 kilobytes in order to put other files ahead of other files. So you can do whatever you wanted here. And there was another return to master key. It was used in another place where it would check if the extra length was greater than 0. And so in one place it didn't check if it was greater than 0, and another place it did. And so, yeah. This would allow you to build entirely unrelated sequences of files in the zip file, skipping over each other in order to construct one zip file that would verify and another zip file that had your exploit and that were unrelated. And then there was this third master key exploit. So the lesson here is that you need to be careful with signed and unsigned values. So there was a lesson with the hash tables that if you have different hash implementations and things, you can end up with different interpretations of data. The lesson here is about unsigned and signed data. The bride of master key is that the zip file format contains the original files, and then it contains an index at the end of the file. And the files all have data about file, file data, data about file, file data, data about file, file data. And then at the very end of the file was the index that helped you more rapidly find all the files. Parts of the Android verification system checked the file headers, and other parts of it checked the index headers, which meant that you could cause the name to be longer on one side than on the other, and like look up a name and then not find file in another place, or lie to do the skip checks. And so you have to be careful if you have a file format that has multiple ways of representing the same data at the same time, that you can abuse that. You really should avoid having file formats that are like that to begin with. But if you're going to have that, you have to be very careful that they're all the same. This class of issues are all called parser differential issues. And parser differentials are when you have one system that verifies something and then another system that uses something, and they've got different implementations of the underlying parser of what the data was. This is particularly often used in the system of a class of bug called a talk tool bug, which is a time of check versus time of use bug. I thought I had a slide, maybe my slide might be right after these. I thought I had a slide here, which was Jeff Forstall, Black Hat, presenting my tool, because he was like, well, I was going to provide a proof of concept today. But it turns out the Jerry's, the front row there, actually beat me to it by 2 months. So, and his tool is way better than the one that I was going to build, was because his works every phone. So you should just use James. The Hollerwort was the name of the Futex Requeue bug implementation that I mentioned GeoHot earlier. I was trying to get Hollerwort to work on the Android watch, because I figured out that the new Android watch that had just come out had the bug that he had found in it. And it turns out GeoHot, like months later, I was asking all sorts of questions about everything, and I had this slide ready to go for all these things. And he was like, Jay, if you had just showed me this photograph, I would have dropped everything and helped you get Hollerwort running on this watch. But I didn't show him in the marketing effort for it. I think this is just here. I don't know, maybe the Futex Requeue bug. Was always so complicated that it never made sense to have Slido slides for it. I'd spent a lot of time implementing the bug, but I never could remember how it worked. Even when I would try to look at how it worked, it was a moment because it was so complicated and the code was so complicated. But so I just kind of mentioned this issue here. But no, but there's a lesson. The lesson to be learned from it is that this watch came out, and this watch, where's the slide? This watch came out with a bug that had been fixed 6 months earlier. And so if you fix a bug, you need to make certain that you actually fix it across your entire organization. Otherwise, you're going to end up releasing new devices that are subject to old bugs. because now's the reason why I was talking to Jihan about something he hadn't worked on in a long time. It was a complicated bug, but he built it in that. So Loki is a bug we used to jailbreak the Samsung Galaxy S4. So is a relatively simple, just high level logic issue. Is that you'd have like a set of images for the file system in Flash. It would decide which one to use and load it. From the image, it would load the kernel and the RAM disk. And then it would take the kernel, copy it to a temporary buffer, and verify the signature of the temporary buffer. But the problem is that it already loaded the kernel, and the location that it loaded the kernel and the image at were specified in the image. So the image could specify to load the image over the code that did the signature check of the temporary buffer. So the lesson here is you can't trust data until after you verified all of it. So if somebody is giving, like here, they trusted the offset of the data before they verified that the data was even valid. So that wasn't okay. Zerg Rush, which I think is the last bug in this I've got here. Zerg Rush is a simple buffer overflow in some sense, where there's a maximum number of command arguments, and then it loops through all the command arguments, and it does a check on them, but it doesn't actually, later on, it doesn't actually, it just allows you to pass in anything that fits into 255 bytes. You can pass in more than the maximum number of arguments in 255 bytes. And so you're able to just overflow the argument buffer, which is only allocated to that, and then overflow your stack, and it's a fairly simple stack overflow bug. But how do these stack overflow bugs work? And that this will kind of culminate into, not that anyone's here anymore. But the get user function we have here, it allocates a 64-byte buffer on the stack, and it calls a function called gets, which is going to, this is a toy. This is not net, this is a toy. Function called gets, which you load in data. So gets does, it takes one line of text the user types into the command, into the console, hey, down run, and it then loads that data into the buffer that you give it. And then we're going to duplicate it. We're not going to make the mistake of returning a stack allocated piece of memory. We're going to allocate a copy of it and return it. But the problem is that the function gates doesn't care how much data you type in. So you can type in more than 64 characters. And if you look at this, it actually even has in the man pane, it tells you that this is not to be used. The gets function cannot be used securely. Because of its lack of bounds checking and the inability for the calling program to reliably determine the length of the next incoming line, the use of this function enables malicious users to arbitrarily change a running program's functionality through a buffer overflow attack. It is strongly suggested that the fgetS function, which takes the size, be used in all cases. But what you can do with this is that, so if you look at the code that's calling this is an ARM 32, actually it's in Thumb. We've got a branch and link and exchange from Thumb to potentially ARM to the gets function. And then that will return back to there. And then we call str to return. The issue, if you can actually look what the stack looks like. The stack came in and with whatever arguments were originally on the stack, which in this case is the pointer to data. And then it pushed register 4, register 7, and link register onto the stack. Then it added more space to the stack after it for where the data will end up going, like the end up getting read to. But the stack grows left. So the stack in these systems grows down. So we put first R4, R7, and LR onto the stack. And then to the left of it, we put all of that extra data, the data array. So the stack pointer is now pointing at that region there that I should probably have made it wider to be less confusing. Because like technically to the right of link register is the register that contains the pointer to data that we were returning. Oh, actually, no, wait, that's right. Because I didn't take any pointers. I'm just returning a pointer. Okay, so that's actually, I'm causing a confusion that wasn't there. So the stack pointer is now pointing at the data argument. And so if you write in more than 64 characters, you're going to overwrite past the end of data, and you're going to start writing over register 4, register 7, and notably the link register. The link register, if you look at the code between the 0 byte and the OX16 byte, you'll see that it changes from pushing the link register and then popping the program counter. So you're going to copy where you were supposed to go to after this function's over into the link register. And then when you're done, you're going to, sorry, it's in the link register. You're going to copy the link register, which is where you're going to go to when you're done, into the stack. And then you're going to put it from the stack into the program counter. So if you've overwritten the stack in the meantime, you're going to change the program counter to wherever you jump to. And you can actually just put that into the middle of the data. You can actually have a person can type code into the thing and then have it jump into that code. So, yeah. Clearly, there are a lot of bugs. I mean, there are a ridiculously large number of bugs that people end up introducing in the software, and they don't even fix them correctly, which is, I think, really disappointing. And the thing that I think is so fascinating about all of it is that it almost feels like I have to remind myself, much less remind all of my users and everything, that bugs are not features. And I stress that bugs are not features because this ecosystem of building locked down devices that are hostile to the user kind of implies that bugs become features. That without having access to bugs, you cannot do the thing that you wanted to do, such as install this piece of software, modify the behavior of this other piece of software, connect your phone to this network that you have access to. These things that you want to do are only possible because bugs exist. So bugs become features, but bugs are dangerous. And we have to keep reminding people to not like bugs, because otherwise people actually hoard bugs. And I don't mean like I'm hoarding the mistake, but like people actually hoard devices that have bugs. I'm using old buggy devices because I can't use the new devices to do the things. Just everyone remember and remind others to not accept that security credentials update that keeps pushing. Random user NXT forums. That is the moral hazard that gets caused when you build locked down devices. You are, when you do that sort of thing, morally responsible for people using insecure software because you've forced them to use insecure software to accomplish the goals that they want to set out to do with your devices. So one of the most humorous stories that I have in the sense of like the saga, it's very not a complicated bug. I go to the big Android barbecue. Cyanogen, who ran CyanogenMod, which was the really big, most common alternative Android distribution that everyone aspired to be, was there presenting the new CyanogenMod installer you'd hired somebody to build. And oh, was it pretty. It was a tool that you just ran on your computer, and it would, I think I probably expected it's a different order, but here's something that's described as a tool you ran on your computer, that's Cyanogen there, Steve Condick, that would just let you automatically and trivially upgrade your phone, just upgrade it to use Cyanogen. Now, the thing that's awkward, and let's go back 2 slides to this thing, is that when you unlock the bootloader of your phone, normally it's really hard. And I always say, it's got a lot of finicky steps. The installer can automate those, but it also deletes your phone. Like it deletes all the data on your device. And it does that. It actually tells you that you're doing that. And that's part of the security mechanism, preventing you from overwriting all the data on the device without first getting rid, prevents you from overwriting the software on the device without deleting the user's data. Because if you could overwrite all the software that's on the device without deleting the user's data, then you could change the way the PIN code lock works so that when they boot their phone back up and they unlock their phone, it just starts streaming all the data to the internet. It's really bad. Like, you don't want to do that. So they added this. Now, I think there's some awkwardness to this, which is that like the way that they often implemented this would allow you to just kind of like very trivially pick up somebody's phone for 3 seconds and delete it. But you could smash it with a hammer. So if you can pick up somebody's phone and steal it and smash it with a hammer, okay, fine. But Cyanogen is saying that he's got this trivial installer tool that just works. And so I'm sitting in the front row so confused. I'm like, how does any of this work? And so I end up, there's a Q&A section. I raise my hand and I'm like, so I don't understand. Like, how did you avoid the phone deleting the user's data? Did you do a backup and restore? I had been trying to get Impactor to support backing up a user's data and restore. Android phones just really, the backup and restore story is pathetic. If you're the only thing they really even sort of support, and even the time they do this didn't work very well, it's backing it off to the cloud. So if you want to like just quickly change all the software and everything, you don't really there's no real good way of doing it. I mean, on iOS, we actually would do occasionally some things on our jailbreak. We would like back up all the user's data, all of it to the computer, then format the phone, then fix it, and then put it all because we could actually always the backup or store stuff is glorious. But like they just didn't really support any stuff. So like, how do you do it? And he just kind of looks at me. He clearly didn't want to answer the question, but he acknowledged because he knew me. He was like, we use some tricks with the cache partition. So I went to JCase and I asked him. At Cyanidion's talk, he said in Q&A about it not doing a backup as it took so long. He noticed about that at the unlock process formats the device, so I would have expected to need a backup. He said they are taking advantage of tricks with the cache partition to avoid that process. That kind of thing came up at DEF CON or something. I think maybe with JCase. There's like an IRC channel. That's a fairly serious bug in the unlock process of these devices. So I think the JCase that came back and explained to me, it might have been Jeff Rosenthal or whatever, that the guy who did the person I mentioned, or Dan Rosen or whatever, the guy who did the info leaks. I think it was JCase that actually came back and I was like, yeah. Here's how it works. When you do that unlock process, you can immediately delete the device. It just puts the command in the cache partition to delete it on next boot. And so if you pipeline 2 commands to unlock the phone and immediately delete the contents of the cache partition, which was apparently a command that you had access to, it would forget that it was supposed to delete the phone. And when it rebooted, you'd have all your data still. And this is what allows you to have this gloriously easy installer, is the fact that this security feature didn't work. So this bug became a feature. And then this is then my kind of pushing on this. This is Mike Lee, who gives a lot of, I think, very insightful talks on ethics at 360 iDev. And actually, it's funny because sometimes we like end up almost trading. Like he's often the person talking about how bad everything is, and I'll be giving people hope. And then occasionally we will do a conference where we will have swapped places, and everyone will be like, "What just happened?" Jay gave us the most depressing topic I've ever heard. But this great slide of Mike talking about how don't be evil by accident. And it's like you think you're just writing software, but you're actually, by way of your poor process, by way of your wrong goals, you are actually making the world a worse place. So I ended up, I think this is what is indicating, that I ended up getting the talk. I retitled my talk to his talk. Not to his talk, to his slide. It was like one slide. I retitled my talk to his one slide and built a whole talk. Don't be evil by accident. It was like this. Simple bugs can actually then have weirdly indirect ramifications. So there was a bug in an Android weather app that caused it to just denial of service attend the U.S. National Weather Service's API endpoint, taking it offline, which broke a lot of other people's very important needs for the U.S. National Weather Service's weather reports. And this is something where it's like the status update that they're using was impacting forecasts. And just bad retry logic. And I kind of look at like our industry has got this horrible problem where it's like we've got this attitude about move fast and break things, which for what it's worth, I think I took this photo in the audience at Fate when he was presenting his new motto, move fast with stable infra. Because Facebook had even realized that if you move fast and break things, things are broken. And that if you're building on broken infrastructure all the time, nothing ever works. And you spend all of your time fixing things as opposed to building new things. And that move fast and break things actually might not be the smartest way of doing anything. And so when we now look at the ethics of systems like the jailbreaks that we do, so Comex, and it was actually in CHPwn, built this glorious user interface, built this jailbreak, which was called Jailbreak Me, which ran on your phone in the web browser. And there was already a jailbreak. There was a Jailbreak Me 1 from a long time before, and we slide to jailbreak. And there was like a Jailbreak Me 2. Jailbreak Me 3, even though there's actually some issues with like the way the Union FS, we were talking about this at the end of last time. Jailbreak Me 3 was just had this glorious user interface that looked just like the App Store. And you'd go through, I think this will start playing, yes it did. And you'd click on and you'd start installing, And it would work just like the App Store, where it would just close, and then there'd be an icon with a progress bar as it downloaded the actual copy of Cydia. And then when it was done downloading and installing the jailbreak, you didn't have to reboot or anything. It just would magically work, because he had injected all of this stuff into the kernel, relayered the file systems. He had injected from the web browser into Springboard in order to pull off this user interface that looked like an app installation. The whole thing was beautiful. The bug he was using was a bug in the PDF file format. Well, it was a bug in the true type font format, I should say, not PDF. It was a bug in the true type font format that allowed you to, and the reason why PDF files are relevant is PDFs allowed you to embed a true type file. True type files allow you to add something called a programmatic hinter. So when you look at resolution text, it gets super blurry. And that first line is what happens if you just kind of like take the pixels and just try to put them in the closest location and sort of approximate and you just downsize it, you resample it. But it's much more readable if you do that second line. Where the second line works is there's a little virtual hammer and chisel that sits there and pounds the font into place. I've got a lot of opinions whether that's a good idea or not. Windows fonts look horrible because there's these hammer and chisel that's messing with all the fonts. All the metrics are wrong. People saying that Max fonts look blurry on various monitors because they just kind of like try to make the font look too accurate. This also will, if you've got like monitors that take advantage the order of the red, green, and blue pixels, you can do things like forgot the name of it, but like the color version of this hinting, where you like take advantage of like, well, something with its blue will look slightly to the left to something that's red, which looks to the right, and so you can end up with like pixels between lines and things like that. But the program that does this comes with the font, not the coloring part, but the program that does the hinting engine comes with the font and a little bytecode that gets executed. So Jailbreak Me 2, I guess is one that it's easier to describe here, as there's a little stack for the little virtual machine for the font. And when you have certain, it goes through and it verifies that you don't underflow the stack by trying to pull more arguments out of the stack than exist. But when they go through and they decode certain sets of operands, and they also they have to add things to the stack and want to verify you don't overflow the stack. But when you look at some of the instructions, like this random instruction, it like puts things onto the stack, but it puts onto the stack after, I think it was the issue is that it checked to see you didn't overflow the stack. Like it's like the order of these operations is flawed. And you end up in cases where like this dupe one, I think, is where it uses one extra stack argument than what was expected. Here, like, I think it just verifies that you don't. Oh yeah, because it's the number of operands even. It's like verifying that like if you add things to the stack that it was fine, but dupe doesn't use any operands. It like just pulls things off the stack and adds it to the stack. So you can overload the stack, and the very next thing after the stack, I think I've got here, is the pointer to the top of the stack. And so if you can go past the stack, overflow the stack, the next thing you write to is where the stack is located, which then allows you to write on the stack and scribble over arbitrary parts of memory. They fixed this bug. Of course they didn't fix this bug. So they fixed this bug by adding some checks, but the thing is there was actually like a second version of the runtime. There's always a second version of the runtime. Why build one runtime when you can build two or twice the price? So there's a second version of the runtime that then was checking for, and then also this call other subroutine mechanism. And this is, I provide all this stuff here, and sometimes I am good enough to try to go through, but it's not a new kind of bug. This isn't like the other ones where like there were like lessons to be learned from these, and this is just like a stack overflow type of condition where you're checking the wrong thing at the wrong time. We had better versions of those earlier that were easier to understand. But I think even I usually have these slides hidden where they don't go through. Maybe when I did the Hack Illinois one, I was like, really, I actually like knew all of it. But the reason there's a moral issue is that this true type font issue existed in everything that used libfreetype, which was the common implementation on open source systems for true type font rendering. Like this is like the font format's weird because it lets you run a program in. And then FreeType lets you had a bug in it that had a Stack Overflow. And so immediately after Comex actually published this bug, there were exploits for Foxit Reader on Windows. There were exploits for anyone running a Linux machine, because that was like the default TrueType font renderer that rendered everything. And so Comex, in order to help us build, like I always describe jailbreaking, is the process of letting us, modify your device like the Game Genie in order to have all these like fun graphical tricks. Like here's a theme that changes all the icon colors, and but not just the icon colors, but also like the little bubble colors and everything. Like it's a theme, all these things. But jailbreaking is actually the process of weaponizing exploits of zero-day vulnerabilities to be wicked and stuff. And in the process, there's a lot of collateral damage that ends up coming up. And so that's kind of why we are, yes, gray hats. That there's that like Jeff Forstall likes to really think of himself very much as a white hat hacker. And there are people who are black hat hackers. So this comes from the terminology of, well, not terminology, but like the visual paradigm of cowboy movies, where like the bad guys wear black hats and the good guys wear white hats. And that way it was very obvious who the good guys and the bad guys were. But the gray hats are doing things more like Robin Hood, where it's like Robin Hood was doing something that was arguably bad. You can come up with an objective set of ethics where stealing things is wrong, and the king, evil King George or whatever, or Richard or whichever one wasn't stealing anything. I think George is a god and Richard was a good one. George wasn't stealing anything. George was just abusing his power and privilege. But Robin Hood, but that was itself immoral, even though it might have been okay from the perspective of like property or something. And so the Robin Hood steals from the rich to get the poor in order to rebalance that. And you end up in these situations where it's like we gray hats are fighting a war with hoarding bugs in order to allow people to continue to have access to the machines that they own, also to understand the machines they own. Because our ability to find these bugs has been predicated on the fact that we already have bugs that let us get into the system so that we can see the bugs. And so in these situations where it's like that the people who make these devices have caused bugs to become features, we end up being put in this awkward position of having to enable like whole exploits. And there's one of the things that's sad about this is that like Jeff Forstall held a bug for responsible disclosure, and Google, first of all, actually, other people can find bugs if you hoard them. So you can't know that even if you didn't tell anyone about them. If I found it in 2 hours knowing it was there, or somebody else who just spent all the time looking for stuff probably had found it, after spending a month just scanning around everything, the people might have already been using and attacking that bug. But additionally, Google didn't even fix it. Google put off until the day of Black Hat actually getting that patch out. And then they only fixed the one bug. They didn't fix the second, even though Jeff told them about it. And they certainly hadn't fixed the third one that got announced on one. So it's like and there's issues with like bugs in general, and dealing with them. Like it brings there's so many interesting ethical questions that bring around this. One of which being, and this is the thing that I think is really like what Comex did, is that Comex had the belief that software is better if it's open source, and that all software should be open source, and that all his exploits are open source. I disagree. And this is something that's occasionally led me to like be in difference of opinion with some people. Like I think it was Eva, but it was even like Cory Toro, whom I have a lot of respect for in a lot of things, and he and I think it was Eva, had like put out even like a bug bounty program to try to find jailbreaks. Also, I think sometimes Cory doesn't quite realize that like these bugs graphically aren't just you aren't guaranteed to find them. But there was like a bug bounty program in order to get an open source jailbreak, and open source jailbreaks have way quicker collateral damage. If you make a closed source jailbreak and release it, like if Jailbreak Me had been closed source, that is the difference between whether somebody who is simply a slightly advanced power user sort of developer and somebody who actually knows how to build these complicated exploits is able to retarget the exploit. how quickly is it that something gets released? Now, of course, maybe the government's already had the bug. Maybe corporate espionage is very rapidly able to find a very intelligent developer with very questionable ethics who's willing to repurpose the concept of the bug and rebuild all the exploits. But when you get down into the weeds of there's somebody who is trying to stalk their ex-wife, there is somebody who is trying to do something as part of some kind of relatively petty crime, but that is maybe very damaging to some small number of people. I'm not equating the stalking as, and then petty crime might be like some small amount of theft, like you're just like stealing a phone or something. I think that the open source exploits have this problem where they get rapidly repurposed. And that was actually the thing that I mentioned over here. Somebody very quickly managed to just kind of recompile his exploit in order to start attacking all these other systems that were not part of Comex's moral goal of trying to open the phone. And so I really end up like there's certain parts of what we do that I think that I totally understand when people obfuscate them even. I tend to not obfuscate my stuff. I don't, when it's like a security critical component, I may or may not open source it. Most of my stuff is open source, but like I've spent so long staring at these uphill questions. It is not obvious to me that any of this should be open source. And I kind of err on the side of making now things that are like jailbreak exploits closed source. So here's a photo of Jeff Forstall that I usually had earlier, responsible for the first responsible disclosure policy. And here's the slide I thought was going to be earlier of him telling people to use my exploit. And this is the lesson here. The reason I put it here was because everybody said is that like people think that they are going to hide a bug, but it actually is very easy for someone else to find it. This is a case, the fail overflow PlayStation 3 hack, where fail overflow had found a bug in the PlayStation 3 that allowed them to escape like one, I'm going to butcher this, but like escape one protection level. And that allowed you to escape. So you can install other OS, which was you could use other OS to install Linux on it, and they kind of escape from Linux into like the more like the kind of hypervisor environment in order to run a and use all the hardware. You can even run a pirate game, as I think a big concern that PlayStation, Sony had. And so they decided to remove other OS. They decided to take a feature away from users. And GeoHot hated that. And so GeoHot went through and continued the bug to escape the hypervisor itself and allow him to completely pwn the device. It wasn't particularly a new bug. And actually there was a bunch of controversy behind the scenes of like, oh, GeoHot's getting credit for the fail overflow bug. But fail overflow didn't, they chose what they wanted to get out of it. And it took somebody like GeoHot to push it a little harder. GeoHot and many members of Fail Overflow were then sued by Sony. And the lawsuit, I always get stuck at this slide. Bushing ended up, he died in December around this time period. And I keep getting, every time I get this slide, I like reminded of it. Yeah, anyway, Sony got, and the thing about what was kind of interesting in some sense about this is that it almost turned into more of a battle in court, and it turned into a battle a battle on, like, almost more of a PR battle than a battle in court. And I'm not set up to screen share this video from there. Oh, you know what I am set up to do is very easily. And since I'm putting this together, I will just go through and complete everything I'm saying today. So it is light it up. That's what I want. There it is. I'm going to click there. Then I'm going to switch my audio
Yo, it's
No, Vincent, I think that was just Zoom. Didn't.
Yo, it's GeoHot. And for those that don't know,
Okay, now
get
it's
sued by Sony. Let's take us out of the courtroom and into the streets. I'm a beast, at the least you'll face me in the Northeast. Get my ire up, light my fire. I'll go harder than Eminem went at Mariah. Call me a liar, count me in the F. I'm no Luke Chafin. You're fucking with the dude who got the keys to your safe, man. Those that can't do bring suits. Cry to your Uncle Sam to settle disputes. Thought you'd tackle this with a little more tact, but then again, fudge packers, I don't know jack. I shed a tear every time I think a lick sang. But shit, man, they're a corporation, and I'm a personification of freedom for all. You fill dockets like that's a constant foreign to y'all. But lawyers muddy water and TRO stall. Out of business is jail for me, and you're suing me civilly. Exhibit this in the courtroom. Go on, do it. I dare you.
There we go.
that Jay, by the way, that's just a brilliant. Is he a musician at all, or is he just?
No, he just, I mean, and a lot of people would have said that that was not an example of music. So I like it. I like it a lot. So I'm glad that you enjoy it. All right.
And
I don't know if I've actually poked GeoHot to tell him that, by the way, I have continually replayed this video that you did this one time.
I've
Sony.
seen, yeah.
But so GeoHot, what ended up happening is that like GeoHot wanted it to, okay, I said the other side. Sony wanted it to be that there was, no, it's more funny the other direction. GeoHot wanted it to be that there was like this mega national company that was like suing the like local kid in Jersey. So he wanted it to be jurisdiction in Jersey. And then Sony wanted it to be that there was this like patriotic California corporation that was being screwed with by this punk kid from Jersey. And they wanted it to be in California. And they wanted it to be like Sony Online of America, and GeoHot wanted the prosecutor to have to be Sony of Japan. And the judge, the argument that Sony had for putting it in California and using Sony Online was that GeoHot supposedly had a PlayStation 3 online account and had used PayPal to collect donations related to the exploit. And PayPal is a company that is headquartered in California. And the judge decided that it would be ridiculous if people using online currencies such as PayPal, that everyone would end up in her court. That there was no way that she just couldn't take on the idea that like we would now be responsible for anything that happens on the internet going forward. It should not be the jurisdiction based upon your payment processor. And the other issue was that there was no good evidence that account that GeoHot supposedly had was actually his account. And as far as I know, somebody actually even they finally found out that it wasn't his account. Because much like me, you'll find that people will make accounts as me because I'm just slightly famous enough that people will do that. And GeoHot was, particularly on the PlayStation, sufficiently famous that people were creating accounts and kind of sticking his name on stuff. And it's like they finally demonstrated that the information was mapping to him, yada, yada, yada. So there was no good argument that's jurisdiction. They ended up settling out of court. I don't really know what happened, but one thing does seem clear is that Sony didn't really want Sony wanted fear out of this. And so it doesn't seem like GeoHot has been hampered horribly. We'll say that for the public. But he's not allowed to say anything, clearly. He's not saying anything. And so I think that's where these companies try to go for is like, well, if no one knows what happened, they can assume it's really bad. It has seemed like it is the case that if there is ever an exemption from the jailbreak, that we might see GeoHot then attacking the PlayStation and Sony with a vengeance of force. But there currently is not. And earlier I described the work that Kyle and I did trying to get a jailbreak exemption for that for video game consoles, and we didn't even get the repair one that time. And I think now we've got finally something related to repair. We do not have general jailbreaking. So. Oh God, it's going to play email. I don't want to skip. There we go. Good. So, actually put a slide at the end of this thing, summing stuff up. So I don't think that security comes from having unit integration tests. I think that those are useful. I think that those can be useful, but I think people think that they are a security practice more than a big behavior practice. And so the fact that we keep seeing people try to work in an environment where they've got a million monkeys all patching stuff, and then they're relying on unit integration tests to find things. Your integration test is probably not finding the bug, and your unit test, honestly, is probably also flawed. The issue is we're finding bugs in your tests, and so you need to be building systems that are less subject to bugs. You need to be don't test your way to verify you're not going past an array. Don't use an array that lets you go past the end of an array. And that's where defensive coding isn't really the strategy either, because is only so defensive you will succeed in being. You're going to try to check a lot of inputs and verify them all, but you might not remember to check everything, even if some places you were checked all the things. If you also hear a lot about don't repeat yourself. I very much underscore this. People sometimes, even a lot of weirdly, that's frustrating me. There are people who are like worship unit tests. And those same kinds of people will sometimes come back and be like, yeah, but don't repeat yourself. That's not something that's like, that's one of those things that those like purists will believe. It's like, actually, this is really important because you'll end up fixing a bug in one place and not fixing it somewhere else, or you'll end up with two implementations that will differ in their behavior, and that's the source of the bug. Do use secure languages, like I mentioned, so right, but avoid the possibility of these bugs.
And Jay, just secure languages you're referring to here are.
Oh, I'm wide. I mean, first of all, secure languages are a spectrum more than necessarily a Boolean. But I mean, if you're coding in Java, you are not subject to all of these mistakes that people are making in C. If you were coding in Rust, you are maybe also not subject to these mistakes people are making in C. You are still subject to some of these bugs. I mean, some of these bugs are mistakes people are making in high-level thought processes of programs. But the extent to which tiny little array offset bugs come back to bite us over and over and over again is just brutal. And so coding in languages like C, particularly where you can't even quickly construct yourself a scaffold to help, at least in C++, you can start building yourself abstractions to try to protect certain use cases. The coding in C is just almost ridiculous. Measure twice, cut once. I have on here is maybe a good thing, but I know what it is. Yeah. Here's the thing. It's not trying to say. I was going to say it's kind of like defensive coding, which I'm not. Which I try to code defensively, but it's not like the thing. Measure consort. I think people don't read their code anymore. They're not careful when they type. They what they end up doing is they lean on tests. And then they assume that their tests will be sufficient. And then they can almost randomly generate the program with a bunch of monkeys at typewriters. And then as long as the tests pass, it's good. And I'm like, how about you read your code, understand what it does, and prove to yourself that it works before you even try to test it? And so I carefully, I write, and then I read, and then I reread my code. When there's an issue, I don't edit and test it. I read it again to understand where the issue is. I figure out if I can prove to myself where I'm making that kind of mistake. I try to internalize that intuition that would come from not having made that kind of mistake in the future. And then I move forward with what I'm doing. I find this attitude that like we should be optimizing for fun and velocity instead of understanding and correctness terrifying. And I weirdly think that the unit test people are part of the problem here, because they seem to think that they can build tests and then rapidly change code willy-nilly as long as the tests pass. And I hate it. I don't think you can handle errors. I think that the premise of handling errors is flawed. I think that languages that force you to handle errors, I mean, it's better than not, I guess, ever checking an error, but like, it's like the languages that are forcing you to handle errors are doing the wrong thing at the wrong time. What you really should be trying to do is get the error to somebody that matters, and that might be to crash the program and let a supervisor restart it. And that's where you start seeing systems like Erlang with their supervision trees. It's been weird to me how confusing Orchid has been when I show it to people, that like they'll like take the Orchid daemon crashes a lot. Like, did it crash or did it close? And they're like, what's the difference? And I'm like, well, if something really bad happened to one of its dependencies, I don't have Orchid sit there, try to fix the situation, retry a bunch of things. I just have it shut down. Because the assumption is that you'll have it running in systemd or some other supervision mechanism, like the Erlang supervision tree, except the way you do it in Linux, that will automatically restart things as they fall apart. And so if you are automatically restarting the OpenVPN daemon, I need to restart everything anyway. Why am I trying to rescue my whole system with a bunch of error handling and behaviors? I'll just kill my program and let systemd restart it. And now systemd will make certain that my program is run after VPN, the whole thing should work. If it's not, I'll just close it and let you just keep going until eventually the right system comes up into place. Carefully isolate processes. If you've got, don't put everything in one place. This is something where I didn't have bug examples of this, but I mean, this is something Google Chrome does this well, where it's like if you have to escape from one process to another process to pull up your bug, it's way harder. Update your dependencies. A lot of people build their program once, and then they just keep messing parts of the code. And you don't realize that, like, the version, it might even be like an ABI break, sadly. I mean, there are other issues in the ecosystem that cause this to be a problem. The reason why this is complex is actually an ethical question on other people not maintaining software that they should be maintaining. But updating your dependencies can be it can be very important, because sometimes people can fix a bug and that you just end up shipping forever. I didn't have examples of this, but you're not a cryptographer. And so building cryptographic protocols is something you should try to do anything you can to avoid. This is like, if you're like, well, I know how signatures work, I will like the math of signatures work, I will just do the quick RSA check in order to verify it's correct. Actually, there is so much effort that has been put into how you pad an RSA signature, or what order you have to do the set of operations in some ECDSA handshake in order to make it so that no one can learn anything. That all of these that you don't accidentally expose information about your key. And those are sometimes extremely complicated cryptographic protocols. And you look at like RSA 1.5 signatures, and like it's a complicated stack of stuff. They took them bugs to get there. I don't think anyone actually has any bugs in 1.5 now, but if you try to make one up from scratch, you're probably going to be re-implementing cryptographic protocol bugs that people have fixed a long time ago. I think security is everyone's job. I don't think that you can have one person be in charge of security and everyone else be in charge of, I guess, insecurity, right? Like if there's one person who's sitting around trying to make certain that everyone else is doing the right thing, I think that they're going to be outnumbered by the sheer amount of mistakes that get put in everywhere. And security also often ends up turning into a cross-domain problem, where you've got systems that you did think were related to security that are making assumptions about other systems that were wrong. And then it turns out that those assumptions would end up causing your problems. And so while like whose job between Bash and CGI and Git Web is the shell shock bug that allows Git Web to be remotely taken over using HTTP headers. It's not obvious to me that it was Bash's issue. It's not obvious to me that it was Git Web's issue. Might have been CGI's issue, but also it's not obvious to me it was CGI's issue. Or maybe it was Git Web was doing the wrong thing by piecing these pieces together. So, I don't know. Produce your attack surface. You can build something smaller. Build something smaller. I think a lot of people end up trying to throw the kitchen sink into everything, and it ends up making things really difficult to secure because now there's a million ways of talking to it and communicating with it. Instead of having two ways of communicating with something, maybe you've got one way of communicating with it. If somebody needs to communicate with it using a different API interface, give them a library on their end that they run that will adapt to the interfaces. Try to keep the things that are security sensitive small. A story here actually is that Muscle Nerd was always very excited every time he released a new type of connector feature or a new USB support because he knew that that was going to introduce some new opportunity for bugs in the bootloader. Because the iPhone had this very thick attack surface where it had the full USB stack it still does in the boot ROM. Whereas Android devices, I talked to them. Because I even like almost complained that like your devices are so easy to brick. Like you'll mess with the flash in some way, and then you will no longer boot anymore, and so you can't get into recovery modes anymore. So you can't use the recovery modes to talk over USB to fix it. And the answer was, yeah, you need a serial cable to fix it. Well, no one has a serial cable to fix it. And they were like, yeah, but here's the issue: serial protocols are easy to write, and we tend to get them correct. And the USB protocols are difficult to write. And Apple has had multiple bugs in their USB stack. And so our serial port stack is more secure to hard code into a phone than having to hard code a USB stack into a phone. And so like the USB bug, like what happens if you send multiple USB commands overlapping at time and all sorts of horrible behaviors that they have. It's too thick of an attack surface. And I think it's really useful to study past vulnerabilities, to go through and to learn from what has been done before, because that starts to give you, when you start coding, you start to have a feel for the things that you might do wrong that other people can attack. It might seem inconsequential that you didn't check some error until you start to actually see how easy somebody was able to attack a system that didn't check a simple error. That like some little buffer overflow actually trivially turned into an attack that took over the whole phone remotely. So, yeah. Well, that's it. That is this whole talk. And we're at the point where only Vincent is here. I don't know if Murad has been watching the participant list. Side, I was going to try to force myself to finish it partly because you recorded it. So if there's, we just send the link to other people in the class, and they can watch the rest of it when they want.
Yeah.
But I also didn't really want to pay that in class because then they probably would have left at the beginning of the class. And it was useful to me to have people here, even to the extent to which people weren't interacting during the code example parts. So
I am genuinely surprised that I am the only person here. Like not even Alex. Like
yeah, Alex just slapped only minutes ago. But
so
weirdly,
close.
I think that after I got to the concluding slide, and it was like, I guess that part's not.
Yeah.
Jay, can you send me the link?
Yeah.
And I'll broadcast it. I'll put it on the. Yeah, I'll put it on Gotcha Space as well. And I was gonna actually like on your secure coding practices thing, and kind of related to the update your dependencies bullet. And this is really about also what do you say about tool chain versions, and so this is it. I mean, your dependencies are general, right? You're thinking about like libraries built elsewhere, but also your own building, your own practices of what version of what tools do you use to compile what library and all that, and the potential or cross compilation. All those things are also introducing another layer of potential vulnerabilities, right? Do you kind of
Yes.
bundle them all under the same bullet, or
I sort of do. I'm the kind of person who loves, and I don't always do this, and I famously don't do this. So you're going to now hear me explain the complexity, right? But I'm somebody who likes to constantly be using the latest compilers. I routinely find bugs in compilers. I find bugs in compilers and submit them. I report all the issues. I sometimes help fix them. I'm often using cutting edge features that are slightly broken. I've run into shipped things that have caused me serious problems that were caused by a bug in the compiler. Apple on Mac OS 10.7. Their C++ standard library is compiled with a broken version of Clang that makes parts of the C++ standard template library not functional.
Yeah.
I like using the latest compilers, the latest libraries. I'm also somewhat famous for using an ancient compiler. And the reason why is because bugs are features. And I ran into some issues, which is that Apple decided to make their compiler have a restriction on it. You can't get Xcode unless you use unless you agree to the terms of service on your developer account, and your developer account says you only use Xcode for certain purposes.
Oh yeah, yeah, the Xcode agreement stuff is always a pain to deal with.
They also, and this is, first go through the issues and explain my mitigations over the years. They also decided that, and this is just kind of their mentality, I hate them for it. I have severe moral issues with what they do here. They require developers to use the latest versions of Mac OS to run the newer versions of Xcode, but the newer versions of Mac OS are often much more restricted or have much more surveillance mechanisms in it, or many more surveillance mechanisms in them, such as the Guardian. Oh, I'm forgetting. I'm so bad at nouns. There's this mechanism that they have that will take hashes of programs that you run and send them to Apple in order to verify that those programs have not been revoked, various things. And they actually we're getting to the point in recent versions that I've not upgraded to, where they send every program you run constantly. And if your network is insufficient, it will actually kind of block your operating system until such time that it's able to check things. It's gotten really, I think, ridiculous and unacceptable what they're doing. But I have continued, therefore. Oh, and they drop support for older systems and devices from their compiler, so that the people whom I'm targeting, I need to support old versions of the operating system, because there are people out there who rely on their old version of iOS in order to be able to not have these weird restrictions, are trying to avoid surveillance, or are actively relying on features such as they are blind. It's there's even a person in the community I can point at, Justin Wack, who is a blind developer who was using all of our jailbreak stuff and is starting to write his own jailbreak extensions to improve the accessibility of software that he wanted to be able to use. I think he should be allowed to use it. And he needs to use old versions of iOS to be able to have all the full functionality of all the jailbreak stuff that we arguably this point even used to have. The newer jailbreak systems aren't even good enough to do some of these. I don't know what Justin's current situation is for it, but I'm saying at the time he was giving talks at our conferences even about this stuff. I therefore need to use old compilers to be able to target old versions of the system such that I'm able to ship code to him. I think it's just horrible. I legally was running the issues for a while where it's like, I'm not really allowed to use a new compiler. And so I've got this whole thing. I use old compilers that can run old systems, that can target old systems, that preferably are, if you go back to the original beta SDKs, which is for a long time, people were really whining my code was so difficult to compile, because I was like, there's a tool chain you can use. But I can't tell you much about it. So I would kind of point towards it. The iOS, the iPhone OS 2.0 SDK beta did not have any usage restrictions on it. It did have an NDA. So you couldn't really tell people much about it. You could tell it everything Apple told people that it existed. Apple told people it had an NDA. Apple told people all these sorts of things about it. But like, you couldn't really describe in like weird aspects of using of it and various things, but it was legit to use. And I always ran into this because it's like, one day, it's like, be in this argument soon, with like Apple's like, my stuff isn't reliant upon your restricted tools. But when I'm not in this weird situation, I use new tools. And in fact, I actually will attempt to use new tools to target old systems to the extent to which, like, I hate the way that Apple shoves everything together. So there's commingles all their updates and everything, and everything's reliant on it, updating their operating system, which ends up being reliant on updating the hardware, which is horrible, I think. With Impactor, we ran into that bug. I couldn't even ship to macOS 10.7 because of some STL issue in C++. And I was like, I compile in my own standard template library, not one that I wrote. I compile in the new version from upstream using new colors. And I compile all of that and I target as the older Mac versions. And because I'm not reliant upon the stuff that Apple's providing there, although actually I do the kind of the old Mac stuff, sometimes you have to use the old compiler. But like with ORCID and everything, I'm trying to just avoid using Apple's compiler. I use the current version of Clang from Google's NDK project, which I like because they not only are providing me the Android targets, but they provide binaries for the versions that they occasionally cut, and they do maintenance, and I can actually talk to them and get bugs fixed in their binary distributions, which I have. And they ship across Mac, Linux, and Windows. They ship the exact same version of Clang to all three systems. And so I use the NDK current version of Clang to compile for all target systems except for Mac ones where, well, actually, that's not true. I use that to compile for all target systems, including Mac ones. I actually compile my iOS and macOS binaries. I do the compile part with the Android NDK upstream Clang compiler. And then I link using the copy of the linker that comes with Xcode, because there is not currently a third-party linker that functions well enough for that purpose. But I am excited to have a third-party linker, and then I use that. I can use the current version of the libc++, and I'm able to use the current version of everything. ORCID's built out of the current version of like the whole stack, except for some components from Apple that are weirdly a little bit old. So.
Cool.
So that's my complicated answer to the tool chain updating, is that I think you should update it. By the way, I am world famous for not updating my tool chain, but there's reasons why that are related to this stupid situation Apple's put us into that I think it's their fault. So.
Okay,
people complaining about it, interestingly, don't complain to me about it though, about security. They complain to me about it over silly reasons. Like they like somehow think the new compiler might be faster, or that the new compiler might be. I'm like, the old compiler, you're still able to install apps from 3 years ago on your phone, right? My old compiler still works. It's not like the Apple spending all their efforts on performance enhancements to this compiler or whatever. They're spending their efforts on shifting the parts of the platform out for things. And like, I don't know, it's weird reasons always people end up citing, and but it really comes down to these like fundamental ethical constraints about dealing with and supporting old software that I wish I didn't have to do, because I feel like that should be, there's be something Apple shouldn't be forcing on us by fixing features. Don't fix features. I'm sorry, Vincent, you were gonna ask another question.
Let me just finish typing here.
You're typing a question.
No, I'm taking notes. I take good notes.
Cool. All right. Go on.
I've also got my notes from last year. So one thing I might do is like, especially if I like stick around next year, which I expect I will. I mean, like come back, I'm sure I'll be here again next year. So, although then it would be in person. Well, I can still take notes on my laptop, but I can look between last year's and this year's of this talk and see if I can like union the two and maybe fill in the gaps from one with the other. I don't know. But anyway, yeah, just typing up my notes. Let's see. Apple shouldn't be forced to, and then I started talking and I forgot what I was typing. Oh, fix something about, it was fixing features, right?
Apple should stop. Not that they shouldn't be forced to fix features. I think that they should not.
Yeah, shouldn't be
fixing
forcing
features.
people
to keep using old software by fixing features.
All right. So
there's another weird moral issue that comes up with relation to old systems, which is that sometimes upgrading to new versions of operating systems requires you to have new hardware for various reasons. And new hardware is expensive. So you actually end up with, like, by deprecating old hardware, because you're like, how many people are using that old hardware? The people who are not using the people who are still stuck using that old hardware are the people who are most in need. They are the people who do not have the resources to buy new hardware. And so you are double extra screwing them by taking away functionality and refusing to give them updates to software because they happen to be using an old system. Yeah, I don't know. I really liked, there was a project for the BBC for a while. Well, it's the BBC doing a tech project. You know, how long are they really going to maintain it for? But they wanted to build something that was like jQuery, but that targeted every browser for way longer than anyone else was willing to support it. And I thought that was the most morally great thing I had heard of in the web dev space. I had liked jQuery. I had started using some jQuery. I thought there was a project, there was a tiny little project that needed to have one little, it was a static thing, needed some little animation. And I was like, normally I would do this myself, but that's weird. Everyone else would just drop in jQuery. It was for Let's Cram, Murad. It was the project that Pat and I were involved in. That was the people and Mike, both Mike Senior and Mike Junior, whose last name I'm for some reason not remembering.
Isn't it Kevin O'Connor's?
Kevin O'Connor did not actually invest. He was heavily influential in our investment round, but I think that he did not actually end up investing. It was Mike. No, his name's not Mike Cram. I'm searching for Santa Barbara. The founder and his father, Mike Lewis, Junior and Senior. So there was just like, they just needed a web page that would just like, that was like a placeholder so that they could send it out to a bunch of teachers at the local high schools, like a social network for high school, they provided online learning stuff. Yeah. And I used jQuery and we started getting all these reports of it crashed my web browser. And I'm like, what did I do? It was like literally just like, I just animated one thing, it crashed the web browser. And I finally tracked it down to merely using jQuery crashed Safari 1.0. And the reason why was that there was like some regex that was in there that that would like it was too hard for Safari 1.0 to handle, and it just crashed the whole browser. And I took a survey. I was living with Eleanor at the time. Eleanor, Susanna, and I, of the 3 people who were in my apartment, 2/3 of them, both Eleanor and Susanna, were using Safari 1.0 because they were using the old version of Mac OS that you had to pay for the upgrade actually for Mac OS at the time. And a lot of it didn't work on the older laptops. They were still using PowerPC versions of the Apple laptops. And so it was the whole thing was just like, and I went to Yehuda, because Yehuda was the big developers on jQuery. He complained about this thing, and he's like, nobody uses Safari 1.0. Two-thirds the people in my apartment use Safari 1.0. Apparently, half of my customers are using Safari 1.0 at their high school. They're all using Safari 1.0. And he's like, what? Nobody uses Safari 1.0. Instead, it was almost like he didn't even really want to fix it. Like, it was just like morally bothered by having to support old browsers. I'm like, what are you even doing if your job is to support old browsers? That's the reason I'm using your library, is so that I don't have to think about hard problems. The only hard problem is supporting Safari 1.0. Building jQuery, most of what you're doing is just calling a function that's in the most modern browsers anyway. I've never felt the need to use your library to do something hard other than to support every browser under the sun. It's your job. I don't know. They just got so upset at the whole thing, and they kept proactively deprecating support for browsers. It's just like, this to me is an equity issue. This is like, you are essentially saying to people that unless they are rich enough to own the latest laptops and to have the latest operating systems, they're smart enough to have the latest version of the web browser on every computer that not only they own, but that they then are able to use computers, because they're going to a library that is still using old version systems. They just don't have access to whatever it is that people are building with your functionality, which might be like some government web page, might want to have a form on it. And they're like, we'll drop in jQuery. And because you decided to not support Safari 1.0, you've just disenfranchised a ton of people from the community from being able to file their taxes online or whatever they're doing. It just pissed me off so much when people don't do that. And so this is like one of my whole core things. And then I spend forever in this jailbreak community, where arguably my job is to support all these old devices, and then I get flocked for it anyway. It's like, Cydia sucks because it still supports, even the weirdest ones. Substrate sucks because it supports, all the way down to iOS, 2. And I'm like, actually, that's what makes it good, is that I've managed to finally come up with a thing that works on every single system. I actually don't do a lot of special cases. Substrate just works on every system, because I found the one thing that Apple won't fix on every single, it's not really a bug. It's not even it's a feature that they like. And I've managed to just use it across everything. And then as they remove functionality that they're using, they figure out a way to make it work everywhere. I don't know. It bugs me so much, because I find myself fighting the zeitgeist of no, everything should just be running the latest, whatever Apple says. And this whole community is about not doing what Apple says.
Wow.
Did you finish your question, Vincent? Now let me know that rant.
Let me just a second. All right. So where I thought you were going before you went in a different direction, and then you went on another great tangent, is when Murat brought up updating software, and the flip side of that, I thought it was going to go in the direction of supply chain attacks. Of you have some library, you update it, but there's something with the update or something, and there's a vulnerability in the thing that you updated that then has some issue. And so
that
now
is true. I don't really believe in automated updates. I think that a human should do the update.
But how do you review to make sure that the thing you're using is safe? Do you just have to go through and read parts of it or something?
So there's supply chain attacks are very hard. You probably didn't, for what it's worth, to review the original. So the line by line. What I do, which I don't think really anyone does. I don't I never just let people always encourage you to just say you want 1.0 and then let it automatically update to the newest patch copy, because those are supposed to be compatible. I actually always target Git commits if I can for my stuff. I usually use Git submodules if I can. I think that those package managers are designed to hide away your abstractions are actually stupid. That you actually you want to see those things, because then I actually it shows me the set of commits between where I am with the latest release of Orchid and the latest release of all the projects that I'm using. And I then glance through all of those commits. I'm not doing a very thorough review, I will say that, but I'm not like just accepting, like if the really big issue with the supply chain sort of things are like people handing you fundamentally different software because you were getting it from a third party or something. So like you went to go download Xcode. It's not really that concerning that Apple's going to get hacked and give you a bad version of Xcode. But if you just go to Google, search for Xcode and just download something, that's where like that ghost attack or whatever, Xcode Ghost came from. Is just like people getting weird copies from weird places. If you like are sitting with, if you're like looking at the set of commits, the people who were involved, and the you're looking at the actual releases from projects that have a good number of people, you're not working with dependencies that have got like one person who uses them. You've mitigated a lot of the issue. Not saying it solves it, but to the extent to which you're going to use dependencies on things, that's a much better way of doing about it than being like, oh yeah, I found a random dependency in npm and I installed it, and now I will just let it just upgrade to the latest thing that got pushed to npm, and without paying any attention to what actually ended up getting updated at all. And then somebody sells that package to somebody else, the package name, the credentials get compromised. You temporarily get a different version other people didn't get. If you're working off of the Git repositories that are shared, you're working off the shared tags, you're able to actually like look at the set of commits to verify the people, you're in a much better position. But
What was the part before you started talking NPM? There was like, just make sure that you, was it get things from different people? Is that what you said? Like get different packages? I don't know. There was something. Oh, well, it's.
You can watch the recording.
No, not the recording. Let's see.
The problem with watching the recording is that then you're going to be hearing your own voice.
Yes,
stuff.
exactly. Then, yeah. I thought the recording. Hey, Murat, do you like record for the entire thing until the meeting closes?
Actually, this one
not
I
recording. Murat's not recording. I'm the one who recorded.
Yeah.
Oh, you're the one recording. Never mind.
Yeah.
I would have recorded.
I just lost audio.
But since Shay's recording, we're saving bits.
Okay. I bet we ran out of batteries.
I guess there were sort of two layers of questions there, and I didn't realize they were separate until you started talking about them. One is supply chain attacks, and the other is more generally like, how do you choose dependencies to make sure that they're safe? Kind of. Like the supply chain attack thing is just like trusting, oh, if I had this dependency at one point, it's going to continue to be fine if I update it and stuff. And like sort of like only trusting at the start and then not re-verifying, right? Sort of. Where there's the question of how do you trust the dependency in the first place? What do you do to feel confident that it's safe?
Yeah, I mean, like those are related, right? Which is that like, if you're using a dependency from that no one else is using, it is going to be way easier for somebody to compromise it than if you're using a dependency that everyone else is using. I believe
that might have been what you said.
I believe much different from a lot of people, I think, who look at this sort of thing, that you're best off using larger, heavier weight dependencies from established entities. Like if I can find something from like Apache that satisfies some wide use case, I'm much more excited about using that than I am about using a dependency from npm that's like the one function that does the thing. Because when you drag in a dependency, if you're not dragging, it's not an attack surface you're dragging in. You drag in a large, wide dependency, you only use part of it. Attack surface is the part you use. But when you drag in a large, wide dependency, a lot of other people are also working with parts of that dependency. Everyone's trying to move towards that dependency. I find the way that the npm ecosystem, which largely ended up where it did, because when you use JavaScript linkers, the behavior had been that it didn't really know for sure what you were using. And so it would just take the entire JavaScript project and put it in your website, which you would then ship to users. And it would be like this many megabyte large download for your trivial web page. And so the ecosystem evolved into this miserable place, which wasn't even like a long-term sane thing, because it wasn't difficult to build a tree shaking linker, and people started building them in order to like detect what functions you're using and only provide those back to them and like actually link. But the ecosystem had already gone in this direction of having these little one function dependencies. And people don't even maintain one function dependencies. But these end up just being dead dependencies that eventually their credentials get stolen and a bunch of projects get pwned, because like if there's a bug in that function that's one line of code, there's often no real incentive to fix it. If there's a bug in a function in Apache Commons, everyone's going to keep using Apache Commons because they think it's this large thing you're not going to replace all. But if there's a bug in LeftPad, people build something like LeftPad 2. That's like the better version of LeftPad. And they start advertising. They want to like get cred for having built the better version of LeftPad. And so I find it to be like a wrong-headed on a lot of different levels. But that's where I'm at. Like you can't. This isn't a solution to your supply chain problem because your supply chain problem is unsolved. But this is what I happen to choose to do to mitigate supply chain issues in the work that I do. USB-C to USB-C. There any more questions, or is we done?
Still typing.
Wow, it's got a vibrator motor. I didn't remember. They discontinued this. I think I got it right when they discontinued it, but it is actually amazing. This is the best little presenter control ever. It looks cool. It feels great. It has the right buttons you need, and it's got this cool mechanism. So you charge it, you're plugging USB-C in the bottom. The USB-C port is on the other side of a USB-A port. Something the shape of the USB-A port. The USB-A port holds onto this little. You unplug this and you plug this into the computer, and it comes up as a keyboard. And then you can just click these, and it just, you walk up to anyone's, they're like, you're going to present, here's your slides. Like, can you just plug this into the computer? Plug it in, and then you've got it, and then.
So the USB-A male port is the keyboard, is like wireless keyboard interface, and then the actual, and then the remote is the like other side of that.
It has an 8. Well, yeah, the remote is the 8. This is the keyboard for this wireless keyboard zone, and it charges over USB-C, and it's done over the one hole. So.
Wait, one hole?
Yeah, there's the thing that this USB-A port has a shape that docks into. On the other side of it, so you see pretty deep, is the USB-A port. Sorry, it's the USB-C.
Oh, so it's a USB-A and a USB-C port in one.
Yeah. Oh, I mean, it's not a full. It doesn't have the contact for USB. It just has the shape.
Huh. Weird.
Jay, my final words are, every time I've seen you present this or predecessors to this talk, it always kind of shocked me, even though, I know what you guys are doing. And this is like, I'm actually a very informed being on the planet, right? And what you can do from a pinhole of security to kind of jailbreak an entire iPhone ecosystem, and they've suits tooling to be able to just manipulate things and so on. It's so scary, like when you think about it, that this is such an accessible exploit, or such an exploitable device. I mean, all these devices, essentially every single computer out there. And no wonder, you know, like you deal with like Chinese hackers, Russia, you know, CIA, all these guys, all they have to do is they don't have to rely on even any corporation, any law, anything, but just to let themselves in through any one of these exploits. And we're talking about here, you know, yeah, 5 smart guys, you know, they carry a kind of a in their back pockets, they have a few bugs, and well, you know, if they got those bugs, you know, somebody else has got, you know, a million other bugs as a part of an ecosystem. They're probably trading them, and it's very interesting that we don't hear more about these other rogue operators utilizing these, or maybe that's the whole point. We're not supposed to hear about it because, you know, if something is happening to Joe's iPhone, Joe doesn't really know about this, right? But so where I go with that is there a noble project of sorts that attempts, it's kind of like a variant of a jailbreak that just hardens and secures your phone.
Jailbreaks did that. Actually,
that was one of the services you were doing, I think. But that's because you were not evil, right?
Yeah, but the noble service is going to be something used from the thing that's interesting about it, though, is that Apple has removed our ability to do that. So now when we release jailbreak bugs, we can't fix them anymore, because the thing that we were able to modify to fix the bug is one of the things we can no longer modify. So we actually have, like, it's the whole stack is more dangerous. People used to be that you could jailbreak to get the bug fixed today. And
What did they change that keeps you from fixing the bug you used to jailbreak it?
we no longer have had kernel level, the ability to modify the code in the kernel for a long time.
I wonder if there's a subset of potentially evil things that could be done by somebody exploiting these bugs to almost like antivirus software type service that, or I'm going to call this actually a kind of a vaccine. Can you get a vaccine for protecting only, let's say, your XYZ, some of the services?
That's antivirus. I honestly don't really recommend running them. But that's what antivirus is.
Recommend what?
I actually don't really recommend running them, but that's what antivirus is.
Yeah, but antiviruses are, I think, too after the fact, and
but that's what you're saying. Like, it's some kind of vaccine. That's what the vaccine is doing. Is it's something that after you know that
I'm thinking something. Do you, or let me then ask you, like, are they, how protective are they? What do you think of anti-vax and antivirus
I don't recommend running them.
solution? You don't recommend it?
No.
Do you run any antivirus? Yeah.
No.
So that's what I'm saying. Why not? It's like if they were powerful and useful, then
No, but I think the premise is what's flawed. Is that like the problem that you have is that you're like, the software is buggy, so let's try to fix it. But you're going to fix it, I guess, by detecting things that you know that could be wrong.
Mhm.
It's like we try very hard to not run software that I don't trust. A lot of people apparently don't want to. They want to be able to run untrusted software constantly. They want to be able to run software from people they've never heard of before. They want to be able to run software that no one else is using, that no one else has heard. They want to be just as secure as anyone else. You just need to have more secure systems. And for what it's worth, I think part of the getting to there requires the user in control of when to opt in and when to opt out of that, so that you don't make bugs become features and you don't force them to run old systems that are buggy and insecure in order to get their work done. But like, you're not going to make your Windows desktop secure against untrusted software. You need something with a much smaller attack surface, and you need something that inherently was built from the ground up to not have these bugs.
But I mean, that's not going to happen probably.
Well, so we're all screwed. The Rust developers, I think, are on the right track. Only I think they that's not the right expression. I think that they went too far on a couple things and not secure things. I think that while they were in the process of building their secure execution setup, they also took away error handling that made sense. And they've managed to make something that I think is, because in no small part that, sufficiently less ergonomic than other potential solutions that don't require you to handle errors. And they'd be like, well, you should handle errors. And I'm like, no, actually, you should never handle errors. That was part of the mistake that you made, is trying to handle these errors. And like, I think that they nearly made the world a better place and then flubbed it. And they are fighting the battle on the wrong front. They're trying to convince a group of people that they believe exists, embedded C developers, to move to Rust. And I think that the people who matter are not embedded C developers. I think that they're the people who could have used C++. I think they're the people who are using C++. I think you need to convince people like Google to stop using C++ for Chrome and use Rust. I think that would be a much better thing to try to change in the world than whoever it is that you're thinking is using C, a device that's so constrained that it doesn't have even 1 kilobyte of memory for a exception jump table. I think that person honestly isn't my problem. I think that person is more likely to write secure code than the person who is working with a 1 million line C++ code base shipping a 1 gigabyte large binary. And the Rust people focused, I think, in the wrong place. But I don't know. I'm kind of pissed about the whole thing. But like, not many people agree with me. So
Okay.
I guess I'll underscore that. I think that the actual embedded C developer, the one who is on sufficiently resource constrained devices that they actually are unable to use things that even have small like things, I think that person is already measuring twice and cutting once, because they don't have the resources to waste on those things. They already are in a culture where they're unable to update anything. So they are willing to put the time and thought into it. I think that the person who's able to operate at that level tends to be the more senior developer who is more experienced at avoiding these types of mistakes and thinking through all of the complex corners of the state machine. And I think that the attack surface of a small embedded device is sufficiently inherently small by its very nature that it is way more difficult to cram lots of things into there. And so what the world needed was a language that competed with C++ and Python and was also secure. And there, arguably, that was trying to be Go, but Go included a garbage collector, which made it incapable of being used for system programming tasks. You're not going to build a web browser in a language with a garbage collector in it. No one's going to actually do that. And so they should have targeted And Python, for what it's worth, technically is a garbage collector, but it's kind of optional. Like it's a reference counted deterministic finalization language. That's part of the reason I like it so much. And like I don't know, they flubbed it, but whatever.
Okay. Okay, guys, thank you. I think I'll disappear.
All right.